There we go. You heard the secret. We have a guest instructor with us today. So we actually have James with us. Everyone, good morning. You heard the background over there. We have James Jolie.
Good morning.
So James is actually one of the contributing instructors to the SOC100 course. Former student, alumni, top tier, S-class student, top contender in all of the popular CTFs, and he's going to be with us today. He's all into the pen testing, red teaming space. That's his love. So he's gonna hop inside of his Linux stuff with me because every good pen tester loves Linux. And then he's going to be back again as well too in the course. You're going to see some more content from him. So we're going to have him with us this weekend. So everyone, please give James a good little welcome to the party in chat. Oh, that's the wrong chat. 1 second. Typing in like the main one over here. Cool. Okay, so let's kick things off a little bit here. So where did we last leave off at? We left off over at Linux. Sorry, no, PowerShell. That's right. We got some PowerShell to do. Cool. Who's excited for PowerShell? Who's keeping up with the course content so far? That's a question. We covered a lot in Windows already. Nice. Good stuff. Cap City's with us.
All Windows experts now.
An important skill. KS is trying. KS is underselling themselves. I know they're ahead of things. Cool. All right. Well, let's go and get ourselves started. We're over in the Windows operating system module of SOC100-1, prepare. And this is the lab of PowerShell. This is what we're going to be going through today. So we've got actually a script we're going to be working with. We have commands that we're going to be looking at, sort of like a little comparison. And I'm actually going to go a little bit deeper than what the lab itself covers. Just to differentiate a little bit between what the CMD, so command prompt, what that actually shows compared to PowerShell. We'll do a little bit of scripting in both. And then we'll actually be done with this section over here. So I've actually expanded on it a little bit. Kim saying, just wondered how different the PowerShell commands are compared to C with .NET. Pretty different, Kim. PowerShell is a scripting language. And when you're dealing with programming languages, they actually need to be compiled into executable code, first of all, whereas scripting languages are usually interpreted line by line. You don't need a compiler inside of a software development like an IDE to be able to handle that stuff. And scripting languages are a lot more like English friendly, especially PowerShell. So cool. Well, let's go ahead and open up our systems over here. We want to have our Windows system running for this one. So go ahead and get that powered up if you haven't already, and then hit connect. And I'll talk a little bit about PowerShell here in the meantime. So yeah, I mean, PowerShell is really Microsoft's answer. It's their modern version of CMD that we looked at last week. So CMD being the command prompt, that little terminal here, this little box here on the bottom. This is the original old school cool MS-DOS style command prompt terminal interface to the Windows operating system. And this was around for a good while until PowerShell came to be. And PowerShell was really, essentially, it was Microsoft's answer to be able to have a powerful scripting language that could interact directly with the Windows operating system framework components like .NET, Active Directory, server, and they wanted this language to be able to be something you could pull up on the fly, a little console, kind of like this little blue button right down here. This is PowerShell, and you might see that on your screens or other places where it's kind of like a blue background. And I'm actually going to go and change that. If I right click the title bar, I'm going to go to font, and I'm going to increase the size. Let's put that at like 24. And normally it's a blue background, but we have it configured for black. And you can see there's a bit of a stark difference. That little PS in the front, it looks the same, but excuse me, it's not the same at all. So like I said, it was Microsoft's answer to put together a language where you didn't need to write C code or C# or Java or any of like the popular programming languages during that time when PowerShell was really starting to come to be. And you didn't need to program to be able to interact with the operating system and server, and you didn't have to write software. You could just grab PowerShell, and right out of the box, you had scripting commands, or commandlets as they're known, to be able to interact directly with your administrative needs. Now, not software development, so a little bit different over there. It's not a software development language where you can create full-blown applications and games, even, right? Like C is used with the Unreal Engine, and that's what's powering games. You're not going to be building games in PowerShell. I mean, I guess you could if you really wanted to, but it'd be really, really terrible. So PowerShell, for all intents and purposes, like I said, it's just a very powerful scripting language to interact with the Windows operating system framework and components like .NET, Active Directory, and server. Its primary purpose is administration and automation. That's what PowerShell is used for. So does that kind of clear up any questions? What anyone might be thinking about what PowerShell actually is? Did that answer your question, Kim? Is the real question as well? Clear. We've been given the proceed. Cool. So what I'm going to do is I'm actually going to open up PowerShell on one side, dock it over there, and I'm going to open up CMD on the left side and dock it here. And for demonstration purposes, I'm going to go back to properties on the right side of PowerShell. And let's see, screen background. Let's try to make this like, if I give this like 100. 5. Let's put some more red inside of that. What are the PowerShell? Wait, PowerShell red, green, blue colors. What actually are they? I remember. Okay, here we go. Oh, wait, what's this? What's this? Can I do that? It's probably just going to reset it back to what it was. Okay. PowerShell Noble Blue. Okay, so this is the more true PowerShell color, right? So red 1, green 36, blue 86. So 13686. One 36 86. Okay, this is more like, this is the true PowerShell color. Yeah, Yeah, I prefer this one myself as well. Noble blue, like it's nice and easy to work with, whereas CMD is the old school like MS-DOS version, black background, this whitish gray kind of tone through text. So this is what PowerShell would normally look like a lot more often than anything. And there are some different variations, right? So let's take a look at the first one. If I were to go to inside of CMD and type in PWD for print, oh wait, CD. PWD is Linux. We're gonna get there as well too. It's Linux. It's just really hard to shake. And if anyone has any trouble kind of following along, SS64 is a wonderful website to be grabbing commands if you're not sure about things. Put that inside of the chat. And there's also explain shell for Linux, which we're going to get to a little bit later. But for now, SS64 is going to be your friend. Go inside there as we work through this stuff. So, and let's do this a little bit more properly. So from a PowerShell perspective, it actually follows a verb-noun syntax, which, going back to English school over here, if I were to say what that actually means, it would mean something like get location. Okay, so verb noun. That's kind of how PowerShell is structured, which is a lot different than something like CD over here to kind of see your current working directory. So that's interesting, right? Like that's a little bit different. And yeah, so as KS is saying in the chat, so you can actually switch back and forth between the two. You can just type in PowerShell over here from CMD, and you're going to see how it actually triggers a little PS prompt, and I can hit exit over there and drop back out from PowerShell and go back into CMD. And so like we had CLS to clear the screen, and you can type in clear inside of PowerShell, and we're going to look at these things called aliases soon. So there are some little minute differences between the two, but really the structure, I think, is the biggest change. Working with these commandlets, and commandlets are sort of like packaged commands at times even. So let's take a look at some more variations. If I wanted to maybe list the directory contents of what's inside of CMD, in this directory of C users administrator, I could do something like dir. That's my listing directory command. Now, if I'm inside of PowerShell, I could go and try running dir, and notice that it actually does work. It actually does work the same. And again, we're going to talk about that soon, but the PowerShell version of this is get child item. And as I type it in kind of lowercase, take a look at this, it's actually going to run both ways, but you're going to see a lot of documentation showing you camel case with capitals. Kind of camel case is going to be like capital lower, and such. Now it's going to work both ways. It's not really syntax specific and case sensitive in that regard. And whenever you're in doubt, you can always hit the tab autocomplete. So if I were to type in like get child and start hitting tab, you can see it just kind of fixes it for me right away. But this is the same output, or so it appears, but notice something different here. Notice that we have these columns that are provided to us, and CMD doesn't do that. It just gives you like a raw output. PowerShell doesn't do that exactly. It has mode and then some hyphens, and this is now actually a column. This is a column of data. Same with last write time, same with length, same with name. And the big difference being that PowerShell refers to things as objects. Objects. Hold on, I'm getting pinged over here. Let me mute some things. So PowerShell refers to things as objects, like I said. And what that means is I can call out last write time and work with that value. And I couldn't do that in CMD. And I think we might need to go and do a little demonstration of what that actually looks like. But first, KSJ wants us to see if we can run get groceries, which is not going to work. So you're going to see a fancy error appear. And for those of you in the chat, Barath, Welcome. Thank you. Thank you for joining us from India. Okay, so for those of you in chat over here, when I know some of you are a little bit ahead, like on the PowerShell side. What did you think? Like when you first saw this error statement, what did that look like to you? It's kind of scary, right? Like what in the hell is going on with this error statement? Now, if I were to do something like, I don't know, like this, right? Yeah. Like this is really straightforward, right? Not recognized as an internal command. Cool. Okay. Now, get groceries is not recognized as the name of a commandlet, function, script file, or operable program. Check the spelling of the name or if a path was included. Verify that this is happening at line 1, character 1. Get groceries, category info, object not found. That's a lot. Yeah, that's a lot. And this is actually really bewildering. This is a little scary for students when they first start with PowerShell because they see this, they're like, what the hell just happened? This is very hard to interpret right away, but there is good reason for this. And remember when I talked about that extensibility of PowerShell to be able to do so much more than CMD and work with these things like objects and functions and scripting. This is why it's giving you such a verbose error. And it's a key word you want to start getting used to things inside of the text space, verbose and verbosity. Because a lot of times you're going to be wanting to either increase or decrease the verbosity of error statements or commands or explanations to things. That's a bit of a term to kind of keep in mind. So what this is effectively saying, because you can kind of go right down to the error right away. This is the actual error, okay? At line 1, character 1. This is actually it. You got a kernel panic, Bara? Tried to recover, but I couldn't do. Oh, man. Yeah, well, we're going to get to Linux soon. There's a reason why Linux is going to freak out at you with a lot of kernel panic. A lot more, but don't worry too much. You deleted your lib64 files. I hope you had a backup. You might be able to download them. The beauty of Linux, I'll put that inside a chat for you over here. Beauty of Linux is that everything is a file, so you can plug it back in to the proper location without issue. You just need to find where it is. Yeah, we're gonna get to Linux, but see, if you did that in Windows, if you like messed up with your registry, like Windows could literally break, and it's so hard to recover from a broken registry. But Linux, yeah, you can kind of find your way back. You just got to find the original files, download them, put them back in location. Yeah, James, go ahead. You have something you want to share over there with PowerShell.
Oh yeah, I was just going to throw in that PowerShell really wants to help you out. So you can ask it for help. You can ask it for help with the help commandlet. So if there's a commandlet that you're not sure about, you can always say get help and then start typing what you want and then tab autocomplete, and it'll list out everything that you can do with that commandlet. Not sure how it's going to react to get groceries.
Yeah, I'm actually curious. I want to see what it does. It's actually trying to search, can PowerShell help us get groceries? Let's find out. It's gonna like hang up. No, okay. Yeah, so it's not gonna find it. So
I'll give you an Uber Eats link.
Yeah, so if I do get help and say something like get child item, right? Boom. So you can always use the get help command, as James is saying, and you can see the exact syntax. Syntax is the proper way to format code or string to be able to be interpreted or understood by a shell or a compiler. And you can see, like, it tells you have this ability to put a path and string, filter and string, include and string. So the way that this kind of works, I'll copy this over here so you can start getting better at reading documentation. I'm just going to put that there, and then I'm going to let that error out for a moment so that I can look at it. If I were to say get child item, and I put path, right? That's how this is interpreted. So you want to actually drop those square brackets. It's telling you that this is an option path. And then I could say something like C users. Okay. So I gave it the option of path and I gave it the value of C : /users. And that's where we talked about where it lives on disk. So that's how you actually work with path, not path, but rather options and flags, which we're going to talk even more about on the Linux side too. But you can see right away, it kind of gives us this little directory listing. So pretty cool. And as James said, yeah, we can do get help. So when we're not even sure about the help that we need, we can get help with the help. And you can see actually there is a lot of ways to get help. A lot. PowerShell's trying to be helpful. DDoS, welcome. First time chat. What registry do you exactly in Windows? Oh, well, we covered that extensively in last class, video number 2 on our YouTube. Long and short, it's a giant database. It just holds all the config data, all the configuration data inside of Windows. Short answer. But we go into that a lot more in depth in the previous one. Okay. Also encourage chat, all of you SOC 100 students, feel free. This is a good opportunity. See once, do once, teach once. Help DDoS out. Cool. Cool. Yeah, KS options, switches, flags. They're essentially interchangeable. You're right. The PowerShell version is a switch. They like to call it a switch. Either one's fine, honestly. So let's take a look at this whole object structure, because this is important to understand. So let's see, like we had these columns over here that allows us to call these objects, right? But let's kind of look at something a little bit more familiar. And you've seen Task Manager before, right? So if I were to do get process, and it looks like this, and if I right click the start menu button and I go to Task Manager, details. Okay. Come on. Almost there. We got it. Okay. So get process is effectively a detailed view of like Task Manager. Actually gives you a little bit more information, but you can see that it has like these handles. We have resource consumption, CPU commitment, and the PID. Remember the process identifier, process ID. Really important value for us to keep in mind. Also has the process name over here. It's just actually cut off. So I'm gonna go ahead and do that one more time now that I have. There we go. Yeah, let's go and keep CMD to the side a little bit for now. So take a look. Process name that we have, right? So let's say that we wanted to get the individual process information for one of these things over here running. And to make it easier so that you have a frame of reference, I'm actually going to open up Notepad so you can visually see it as you're learning this stuff. Rather not Notepad++, but Notepad. Okay, so this is Notepad running, right? And get process is a snapshot in time. Yes, Stephen, it is a snapshot in time of the current running processes. This is not a real-time view like how Task Manager actually is. This is updating in real time. So now that if I run get process one more time, we're actually going to be able to see Notepad. Let's kind of scroll right up to, here you go. So now we actually see Notepad running over here. Now, if I wanted to get the exact information of this, I could do something like get process. And we're going to see this more soon, but this is called the pipe. This is a pipe character over here. And it's actually known more as a operator. And we're going to dive more into that. But for all intents and purposes right now, just assume that pipe means take the output of this command, which is this, right? This is all of this output right here. Take all that output and then send it as the input to another command. And another command we can run is called where object. And this is a very commonly used commandlet inside of PowerShell. This is going to allow us now to interact with the output of get process in an object level. That means I can grab like little bits of information in a very, very easy way. And the way that you do this is you're going to open up little curly braces. And this is going to get a little complex right now, a little bit complex, but all good. We're going to walk through it. And what we want to do is type out this, and I'll kind of walk through this in just a moment over here. So what we're saying is we want to use where object, and the property of the object is process name. So that's this right here. And I want to get the object that has a process name of notepad. So this part's easy to read. Now, the part that's a little tricky to read is this. And we haven't gotten into variables yet, but this is effectively a variable. It means that when I run this command, remember we talked about runtime data, runtime values in the previous lesson? And we mentioned that certain values appear only during at runtime, like PIDs. So if I looked at like these process IDs, these PIDs, they're created at runtime, but then they're gone after when the process closes. So a variable is a fancy way to essentially store data temporarily. So we create this value or this space, and it's usually going to be referenced by words or symbols. And in this case, PowerShell just has this as like it's kind of like a special property of PowerShell. It's written in the programming language. And you're going to see as you get exposed more different programming languages, they all have different ways of declaring variables. But what this is saying is to go over the entire list, and it's going to actually loop. Okay. It's going to loop over all of this output. And the command is going to run, and it's going to go like this. Where process.name, check this, check this, check this. It's going to actually go line by line. So it's creating what's called a loop, and it's looping over all of the object data output. Okay. And then finally, it's going to actually go and stop. Once it hits here, a process.name is equal to notepad, it's going to pull the information on notepad. So let's take a look at this, see what it actually looks like. So we ran get process, it gave us the output, and I said, now take that output and put it into the commandlet of where object. So now where object is running on this. This is the input that we're running on this commandlet. And then I give it some additional information. And I say, okay, I want you to loop over that output. And when you find the process name property that equals notepad, return to me just those results. Pretty cool. Pretty cool, right? Start to see that this thing is powerful. PowerShell. It's got a name for that for a reason. Yeah, some good questions popping up in chat over there. PowerShell safe to use. This is a good one. Kind of pin that for a moment. Is PowerShell safe to use? My manager is very leery of it due to some vulnerabilities of hackers taking control of some modules. PowerShell, if you if a user never needs to use scripting or PowerShell commands, you should probably disable the usage of scripting and commands. PowerShell is safe to use, but the chances are if you enable it, it's something could be misused at some point. Because remember what I said, that PowerShell is integrated directly into .NET and to Active Directory and Server and Windows OS? You would need to make sure all of that is secure and safe. Like all the different possible ways you can interact by PowerShell into those different surfaces. You'd have to make sure all of that was tightened up. And that's not an easy ask. So the better option is to just disable it if it is not needed, and then provide permissions to certain users like your domain admins, and truthfully, probably just your domain admins. If I could just be straight with that, probably just your domain admins need to be running PowerShell. And if for some reason you need to create like legacy scripts and things for certain users, there are better ways to do that. But it is a sysadmin, like it's a system administrator tool. Users shouldn't be running around using PowerShell unless they are, maybe they're SOC 100 students learning something and then messing around their company network, and they shouldn't be doing that. They should be doing it on their VMs or at home. You know, like you're going to have students or people that are learning things and you want to be all fancy and stuff and hop in the terminal. But yeah, you should disable it as much as you can. So it is safe to use under the condition that you have mapped all of the possible different ways that PowerShell could be misused, and then put something in between that, which that's so much more work than just disabling the functionality of running scripts. Yeah. PowerShell, you can create keyloggers, you can create reverse shells, you can create backdoors, you can drop malware around, you can do a ton of stuff. And maybe we'll see some of that later on in the SOC 100 series courses. But yeah, I'm glad you asked that question, because that's actually really important to highlight that this is powerful. Like what we're doing right now is very, very powerful. This is not something to mess around with. I wonder how many times I can say powerful and PowerShell and power on this stream, huh, James? Let's just keep going. Okay. Let's unpin that. Yeah. Yeah, Utgar. Yeah, I mean, okay, I prefer Bash myself. We're going to get into Linux after this, but yeah, all good times. Okay, cool. Follower goal reached. Oh, geez. Wow. I didn't have my... I need to set up the OBS plugin that actually shows me the alerts popping up. So we actually... Okay, hold on a second here. DDoS, Confusion, Survival, Lead. Wow, we have the lead survivor here. Crystal Mess, Omar, the only one, Voltan, Chroniosis. Thank you all very much for the follows. Looks like we hit our goal. Very cool. Thank you. I need to have it sort of like in my front view and center, because the chat's on the side when I'm like looking at the stuff and talking. So, but cool. Thank you. Thanks for being here. So yes, we discussed this notion of working with objects, and this is really important to understand. And this is different than working with CMD. So in CMD, I would do something that is similar but not the same. So I would do something like task list instead of get process, and that's effectively the same. Like you can kind of see this whole dump, but it doesn't have the same ability per se that PowerShell does. It's just formatted text. It doesn't actually work with objects. So you actually have to go a little old school and do this little pipe operator again. And you would use a command called find string. And it's actually going to just be looking for the string of Notepad. And you can see, right? Like it just gives me both. You have to be like much more specific. Like I'd have to actually put find string notepad++ if that's what I wanted, or notepad.exe. So you have to be much more specific and explicit with what you're trying to do inside of CMD. And it's much simpler. It is. CMD is much, much simpler, and it's very useful for what it can do. And I think, you know, you're probably going to use both, in all honesty. CMD has easier syntax to remember, right? Like, remember what I said? Like, this is a very long piece of thing to put inside your brain, right? Get, process, where object, variable notation, inherits the property of process name, and equals notepad. That's a lot longer to remember than this, which is almost, in some ways, more intuitive. Even though PowerShell has designed its language of like verb-noun, it creates a lot more verbosity. It creates a lot more stuff to remember, and it's very specific just to PowerShell. The other languages don't do this. It's only a PowerShell thing. So if you work day in and day out in PowerShell, good. You're going to remember this stuff. But otherwise, it's probably going to float out of memory.
Also, I could throw out there, a lot of the command line or command prompt commands will work in PowerShell, but PowerShell commands don't work in the command line. If that makes sense.
This is actually, let's show that. So if I were to do get process, it's not recognized. But if I were to go inside here, right, and I ran dir earlier, it is interchangeable. And there's this notion of, oh wait, I hit tab too early. Let that load. So if you type in, if you type in get, and everything in PowerShell is like get this, get that. But what I want to do is say get alias. And get alias is effectively going to show you all of the different ways something can be called. But if I want to say get alias, get child item, or sorry, rather, I think dir, right? Okay, so if I were to do get alias on dir, PowerShell's actually going to take the dir command, and it's not going to run dir. It's not actually running this. It's actually still running get child item. So PowerShell is going to force the shell to run PowerShell commandlets and just take aliases like this. So dir is a native command built inside of CMD to run, and this gives you a directory listing. And if you tried to run dir in PowerShell, it actually stops it and says, oh, I think you meant get child item. It's kind of like, you remember that Friends meme? Like Joey and Phoebe, like, you know, she's like saying it like line by line, like dir. Imagine Phoebe saying like dir and Joey's like dir, and then she's like, say it all at once. And he's like, oh, get child item. Like PowerShell will kind of do the same kind of thing. It's just going to, it's gonna be like, yeah. So you're saying dir, but I think you meant get child item. So that's kind of a funny way to think about it. Survival, hey, first time. But and mannered frog. I hopefully a well-mannered frog. But Karina, you have a question. Is holding each object in process? Yes. So your question was, is the $_ variable holding each object in the process list as it loops through the list? And yes, it's exactly doing that. So if I were to do kind of like how I had it before, like get process, I'm going to expand this. We'll do that once more. So if I run get process, this is actually a list of objects, okay? And at this point in time, it is saying that each object, so here is an object entry, and this object entry has certain properties of process name, PID, CPU, etc. So what we're trying to do with this command, and I hit the up key to go back up through my history, if I were to run get process, it's taking this output, piping it over to where object, and the where object begins a loop, and it starts going from the top object by object, and it's looking for the process name property of notepad in this case. And once it finds notepad, it just dumps the data on that. So kind of look at that once more, and you can see it has the exact same columns just as before. this is the single notepad object inside of the git process list. Does that help answer that a little bit more, Karina? Yeah. Yeah, Manard. It's a little SQL-esque, yeah. For those of you in the chat that are more familiar with SQL, it's like, yeah, select this where property equals that. Similar, but yeah. So PS over here is denoting that we're in a PowerShell session. And note that when we're inside of CMD, it's not there. But if I were to type something like PowerShell, and I start a PowerShell process, the PS appears. Yeah, cool stuff. Cool. So let's do another little comparison, kind of walking through some commands over here, going back and forth. So the PID over here of Notepad is 2668. So we can kind of do the same thing. If I were to do get alias on stop process, or rather, sorry, task kill. Oh, it actually doesn't even map that, does it? Interesting. So maybe not everything's mapped over. I never even decided to check that. So inside of CMD, you would run something like task kill, and task kill would be a way to kill processes by PID. So not everything is going to be really essentially mapped over it by aliases per se.
You can get alias for kill, and it'll tell you stop process.
Oh yeah? Oh yeah. Because kill, yeah, because they probably referred kill from bash, right? For like bash, you can do kill -9. So yeah, kill is going to map to stop process, but so not everything like task kill is going to be mapped over to aliases in PowerShell. And again, when in doubt, you can pull up this little SS64 website, go straight to PowerShell. And here's a way to look at all of the different commandlets, which is super helpful if you kind of want to just search for things. So if I were to type maybe, and I recommend do like a Control F, do something like kill. Right, so stop process would be the one you'd go over here if you didn't know how to find it. So little like gotchas, you know, and you kind of discover that as you go through. If you need to play with it more, if this is more your domain, you're going to learn which things map where, and just by kind of habit and experience, you'll get through it. But really recommend keep this open while you're looking for different types of commandlets as you need. So cool. So let's go ahead and let's actually kill that notepad process. So this is it running over here. I'm going to say, don't kill me. And we're going to go and do stop process. And we're actually going to give it the ID. And you know what? Let's do the James way. Okay. Get help on stop process. Okay. So remember looking at documentation. So the syntax is stop process, and we can give it the ID. And this is an integer value in this case, which we'll get to that way later on. But we can go inside there, and what we want to do is use the ID option and give it the ID value of 2668. So do stop process ID and 2668. So boom. Goodbye, Notepad.
Can I throw one more thing out real quick?
Yeah,
just because I saw it in the output of help. That tac WhatIf will let you run the command and tell you what would happen, but not actually run the command. So if you want to test your command, you can do the tac WhatIf, and it'll tell you what would happen without actually executing.
Okay. So Notepad's back up. So let's do stop. Oh wait, let's get the ID. Okay. Okay, so this is now ID 996. Remember how I said PIDs change? And let's go ahead and we're going to do, what is it? It's all what if, right? And is there any option that comes with it? Nope. So you just put in this. So let's run it. Not going to work. Oh, sorry, 2668. 996. Okay. So what if perform the operation stop process and target notepad 996? So as James said, like it didn't actually do it. It's just saying what it would like to do. Pretty cool. Pretty cool. Abe, you're saying, yeah, you can kill processes on remote computers. PowerShell can remotely or locally do everything. So everything you're seeing me do here, you can also do remotely on other workstations inside of a Windows network. It's pretty cool. DT Kalani and Utkarsh, thanks for the follow, guys. I'm not sure that question survival. Yeah. Cool. Cool. So that makes sense? Makes sense? Any questions on that? I'm gonna continue otherwise. Do a little bit more kind of comparison. Mannered Frog. You have a question. What is SI? Good question. So that's session ID. But what does that mean? Challenge to the chat. What does that mean? Here, I'll give you the Microsoft. Let me see if I can find Microsoft documentation for this. PowerShell get process ID. It's not Microsoft documentation, but I want you to start getting used to looking at like Stack Overflow and Super User and Reddit and stuff. Tell me what it means. Cool. Okay, so let's do a little bit more comparison while chat has some homework over there. So let's go ahead and we're going to actually... That was a shortcut, by the way. Sorry, habit. I'm going to go and do get process. Get pro account setting. I'm going to do get process, and instead of typing clear, I'm actually going to type in Control plus L. Like on my keyboard, I'm going to hit Control plus L. Okay, and this is a shortcut. That just clears your keyboard right away. So notice inside CMD, no shortcut. So CLS. Okay. Let's take a look at a couple more things we can do. So let's show the difference. We're inside of administrator in both. We're going to show the difference to do something. If I were to make a directory, I would do something like make directory some folder. Okay. And if I ran dir, you can now actually see some folder down over here. And then if I were to go in the PowerShell way of doing this, I could go and do, let's do get alias, make dir. Let's see if it actually has it so that it doesn't, right? So if we go to explain or PowerShell commands, let's go right from the top. You know, it's interesting that this has documentation on it, but it's not actually finding it from the other way around. That's interesting. So what we want to do is use new item as per the documentation over there. And I want to do new item, and I could do help. Or no, jeez. PowerShell. Get help. New item. That's what I wanted to do. Okay, so here's my syntax. And I want to say new item, and I want to use the path over here, and I have to give it an item type as well. So it's a lot more specific. And there's a good reason for that. Let's call this like some folder 2. And item type. Let's go with directory. Okay, so you can see the command is completed. So it gives you the output of showing what it is. And I could even check that out. And you can see that it actually completed some folder 2. So a little bit different than what we're used to from the CMD space side of things. Now, what about actually, let's get some file data inside here. So if I were to do something, remember in CMD, we said like echo hello darkness, put my old friend.txt. And if I did the type command, my old friend.txt, it would show the contents of it. Cool, right? Well, PowerShell version. If we were to do something similar, we could do something like get content. Path. Where did I put it? I put it here locally, right? My old friend.txt. So a little, like I said, a little different. So as I'm going through this, right, there's some similarities. There are not some similarities. There's some alias overlap. There's not some alias overlap. But structurally, the biggest difference is this notion of working with commandlets that have much more increased functionality and the ability to work with objects, and objects have properties, and CMD doesn't do that. That is the biggest takeaway that I want you to be familiar with for all of these things. Let's take another look at a little bit more pipe action now. And you see how we had this command, right? Echo hello darkness, my old friend. If I were to do something like task list, I could also pipe that output, because all what's happening here is, look, remember if I did echo hello darkness, it just immediately drops it as output to the terminal. But it's because I put this redirector here that it goes inside of a file, and then I can read the file after. So by that extension, I could run task list and then send the output of task list to, let's say, processes.txt. Cool, right? And then if I did for a visual, let's go inside here. Let's go to C users, and we're going to go to administrator and processes.txt. Pretty cool, right? So CMD can also just dump data to a file like this. So this is pretty cool. So imagine that imagine you needed to have a backup happening, right? Like a backup running at every certain hour, and you just needed a quick snapshot of like a processes or files or something. You could save that to a file by doing that, by having that little redirector in place. So pretty cool. Now, PowerShell actually has a little bit more granularity to it, as expected. If I were to do something like get process, like how we had before, we would do this pipe operation. We could do that as well, but we could actually get a little bit fancier and have the commandlet of out file. And we could do file path, processes from PowerShell.txt. Cool, right? Go inside here. So this is, like, take a look at the size. The size has doubled from what we got inside of CMD. And that's just because we got more information. And now we're actually able to use terminal commands to bring files to life and use commands quickly on the fly for file operations. Pretty cool. Yeah, out file is kind of like output. So if I did like get help on out file, right? So we can do like file path, string, encoding. There's a lot of stuff you could do. You could write the things. Let's take a look at the PowerShell commands. Out file. So this is pretty cool. Put that in chat over there for you guys to take a look at. And it actually has some pretty neat examples to show you what you can do. You can actually write to a CSV. Pretty cool. Don't even need Excel. You can just do this all in the command line. Yeah, lots of cool stuff. Save a registry key to a file. Fancy. Cool. Max, thanks for the follow as well too. Cool. A little bit more to go on this side of things. So let's take a look at some scripting now. Now, note if I type in like PowerShell over here, right? We're going to see a couple different options appear, even from x86 capabilities. We're going to see this thing called ISE. Cool. So that's loaded. So this is pretty neat. This is a built-in scripting environment, integrated scripting environment for PowerShell, actually. This is a PowerShell only thing. And what I could do is I could go inside, and right now I see it's like created a PowerShell session. I can go and create a new script, and I can actually start preparing multiple commands in advance and creating a whole script for us to work with. Now, I actually do have a script from inside of the lab. I'm going to grab that. And this is inside of here, right in the beginning. So this script right here, you can go ahead, you can hit copy and bring that over to here. And I've actually added a little bit more to this script in lieu of today's session. So I'll drop that inside of the SOC student Discord. 1 second over here. Cool. All right, so a couple things that I wanted to show over here that I don't think we highlighted enough in that initial script. So I'm going to actually go over that stuff with you now. So this is effectively a series of things called comments. And Manard, thanks for the follow. Thanks for being here. So this is, you see how these things are listed out in green, and these are called comments in code, and comments do not get interpreted and they do not get executed. So they have this different color. And if you can put a little hashtag in front of them, you can make a single line comment to explain what's going on. And if you wrap hashtags inside of these little carrots, or rather less than and greater than symbols, you can make multi-line comments, and you can see how you can sort of like expand it inside of this editor for ease of writing code. And every language is going to look a little bit different. This is PowerShell specific, but even like Python has this, like you're going to see hashtag as like a commonly used type of comment ability, or like slashes and whatnot. You'll see each language that you work with over time has different ways to provide comments, and it's all in the documentation of the language. And notice that there's some added functionality going on now inside this script. And you haven't seen a lot of this stuff yet, but we did sort of see a small variable earlier. That variable being the little $sign underscore. And notice how we're sort of using that structure again with the little $sign in front, but this time we're actually going to be declaring variables. And this script is effectively allowing us to create a user. So I can actually go and I can run this script. I'm going to save it first of all. I'm going to do save script, put it inside of desktop. Let's just call this like user gen. So I'm going to go ahead and I'm going to hit this little play button at the top. And notice what happened over here. It's created power user as a new user account. It's given them a password, and the comment inside of it over here is called new user account. Like that's what it actually is. And we've added them as a member to the administrators group. So remember, if I go inside of the old computer management inside here from the GUI side, and then if I went to local users and groups, users, you can see power user has appeared, and they're part of the administrators group. So pretty handy. You can kind of do that right there on the fly. Now, we could also do this inside of CMD. So CMD creates these things called, it doesn't create these things. We use these things called batch files, like .bat extension. And you can use them inside of Notepad. I'm going to open up Notepad and I'm going to go save and call this user gen from cmd.bat, and ignore that little .txt because we're giving it the extension this time. And got some code over here, which I'll put inside of the Discord as well. So a couple things about this script, and this doesn't look as nice and fancy, right? This is a much old school version way of doing this. So a common thing you'll see inside of these like batch files is this statement at top where it's called echo off. And this prevents us from seeing what's actually being ran. And then we have this little pause thing at the end. So this is a bit of a different structure. So this actually suppresses the output of what's going on inside the command, as opposed to PowerShell, which is quite verbose without further specification. And the pause ability lets the window stay open. But we also have comments inside of CMD files written for a batch script as well. We can put in this little rem command. We can put these little double colons. And this is effectively, if you put them in front, you'll see that whatever I put here is not actually going to run. This is effectively saying the same thing as the hashtag comments inside of PowerShell. And all what I'm doing is I'm putting the same CMD commands here. So if I were to go and delete power user, And just to make sure, good, refresh that. The commands being ran over here are net user, power user. With this password, we're going to add them and the comment of new user account. So very, very similar, but you can see a lot less complexity kind of needed over here. And we're actually going to put them inside of the local group of administrators and add them there as well. And then we're going to set their password to never expire. So, like for example, if I were to try to run net user, power user right now, after I deleted them, username is not available. So let's go ahead and I'm going to save this. Okay. And batch files are important to pay attention to because this is sometimes like how little malware scripts can hide. So we put this inside of the desktop, right? So you can see this looks a little bit different. It's got like two little gears next to the icon, next to the user gen PS1 script. And notice that, I didn't cover that, but a PowerShell script has the extension of .ps1. That lets the computer know that this is a script of PowerShell code to execute. And the batch file is a batch of commands with the extension of .bat to let the computer know that when I run this file, there's a series of CMD, so command prompt commands to be running over here. Now, if I were to go and run this as administrator, okay, you can see that a bunch of things happen over here. Remember that window stayed open? So it looks like it all worked perfectly. And the reason why we see this output over here at the end is because the final command, close that up. The final command is this net user power user command. So if I were to go to net user power user, you're seeing the same output. So the script, the way that this executed was it suppressed the output, excuse me, of what was actually being ran until we got to the end. And then it just kind of just like drops it right there. And it's at this like press any key to continue. But pretty cool. So the beauty of scripting, excuse me, the beauty of scripting is effectively you take the CMD commands that you know, or you take the PowerShell commands that you know, or you take the Python language that syntax that you know. That's what scripting is. Scripting is just a bunch of commands put together inside of a script to execute in a certain sequence and automate your tasks. So instead of me, remember we learned earlier on how to go and create user accounts and go inside of computer management and click around, do all that fancy stuff, and adding them all inside here. Well, you can see actually the ease of like building a script to do this for you on the fly. And then maybe we wanted the ability to change the user password when we do it, but much faster. And that's really the point of working on the command line, is that extensibility. The GUI is just going to be able to provide you certain intended functionality to do it that way on the fly. And is great for like one-off management and ease of getting into it. But the moment you start hopping on the command line, all of a sudden you just have so much more power. And this script is for me. Like I've made this script to my needs of what I want it to do. I'm not constrained by the computer management options available to me over here, or clicking around different GUI-based applications that can only do one certain thing. So pretty cool. Cypher, Hades, and Urfom, thanks for the follows. Appreciate it. Yeah, I'll kind of pause there. Let James kind of hop on the mic too. If there's anything that you wanted to sort of add on to that as it is right now.
No, I think you covered a lot of it without, excuse me, without getting into too much of the weeds here a little bit.
Yeah, it's kind of hard, right? Like I want to just be like, oh, look at all this cool stuff, but
yeah,
it's gotta ease you all into it. I guess
Don't
we
wanna
should
do
open up
information
maybe. Yeah. So Steven's saying very cool, but scary for you if used for malicious. Yeah, exactly. And that's what chat was even saying a little bit before too, is you can see how powerful the command line is, like for system administration and running around and changing settings, changing the ability and functionality of the user experience. Does anyone have any questions just on how this sort of all works?
Everyone's on board.
Yeah.
How we ran the CMD script again?
Yeah. So Karina's asking how you ran the CMD script. Yeah, for sure. So what I did was, let's copy that. I actually opened up a new notepad and I pasted the code in that I have inside of the SOC 100 student Discord. And you can delete all this top stuff if you really wanted. And I just put in some normal CMD-like commands. Like I could throw like dir here at the end if I really wanted it, just to kind of show.
Yep, you do PWD. Anything you can. These are commands you would type in the command line, but they're all just getting run at once from this file.
We're going to call this Karina script.bat. So we're creating a batch file. So now we have this script over here. And we're going to go ahead and we're going to right click this and we're going to do run as administrator. And the reason why we're running it as administrator is to be able to use the permissions required to interact with these commands. Because now we're doing user administration, which requires elevated permissions. So we want to right click this file and run it as administrator. And you can see how it kind of hangs open at the end of it. And it's just going to run those commands. And notice that it ran my dir command at the end of it as well. Make sense, Karina? Yeah. Mattered. I mean, if you're looking for resource suggestions, like you're doing it, this is it. Like, go and open up a terminal and think about what you want to do. And this is actually inside of the SOC 100 course content. If I go inside of chapters, I added a new challenge over here. And your challenge is to go and make a script. And I've given you some things to start off with. Your first challenge over here would be to create a script that does the following: finds all files on a C drive that are larger than 5 megabytes, lists them out, and then saves it to a list called largefiles.txt. I've also added some optional challenges. You can sort the list by size, and you can write the script in both PowerShell and as a batch file if you really want to push yourself. You can ask for some help inside of our Discord channel if you need it. And if you're stuck with anything, remember, SS64. Go inside here. You've got CMD and PowerShell commands. You can look them up. There's a bunch of things that you can do. If I were to do like list, right? So maybe dir is something that you want to do. Maybe for. You want to go and play with these commands. Maybe find, right? Search for text in a string of files. Search for strings in files. There's a lot of different things that you can do. So mattered, it doesn't matter what resource beyond at this level. Like I've introduced everyone now to be able to open up a terminal, whether that's CMD or PowerShell. I've showed you how to run commands. I've showed you how to look up command documentation. I've showed you how to create a script inside of PowerShell where you can add more things to it on your own. And then you would just run it inside here. And I've also showed you how to go and create batch files, which just consist of the commands that we've also used as well. So the best thing you can do, and for everyone, go and get your hands dirty. And that's why we have the first challenge. And you feel free to do something different. Like, this is just a suggestion, but go and do something else. Like, maybe make a script where you're asking for a password to be added to a user account.
On a startup script that that opens whatever applications you want to run. You know, you want to run as soon as you turn your computer on is a good one.
Yeah. Yeah. So the course content is not free. It's $19 for the course, but this video, like the series we're doing, is free. You can go back and watch the first and the second one, and we walk you through it. Now, you don't have access to the actual content over here with like the lab steps and everything, but you can follow along and you have your own VMs if you want to kind of build them out, or your own home computer. But yeah, I think that this is a pretty good entry into the Windows operating system. I think we've covered a lot. And Karina's saying, for the PowerShell version of the challenge, I thought about it, and I think I'd be piping a lot of PS commands together. Yes. There is no single way to do this, and that's kind of the fun part of working on the command line and with code. It's your flavor. You could do a lot of piping. You could do a lot of individual commands. Yeah, there's a ton of stuff you could do. Veril, if you glue RAM to a boomerang. I like it. It's pretty good. No, you don't get brownie points, Stephen, because I didn't give you consent to do that. So don't do that.
You get arrested if you do that.
Yeah, so stop that. You need consent. KSJ, is system specific logon? Yeah. Yeah, exactly. Very common. So sysadmins like KS over here in chat, they'll make like a logon.bat file. They'll make a batch file like this to do things when the user logs in. So maybe a user wants to start up with certain applications. Maybe the sysadmin needs to run certain programs to collect information about the user's current level of access and maybe the system performance, and then send that somewhere. There's a lot of things you can do with these types of little logon.batch files. Or maybe just provide access to like a legacy application.
I will also throw out the reason, going back to security, you don't want a normal user to be able to do what we did here. Just create other users and give them admin privileges.
Yes. Yeah. I hope that's a good example. We had questions earlier on like, oh, is PowerShell dangerous? Yes. Like as James is saying, right? Look, we're going and we're creating administrators. Yeah. Cool. Cyber Realtor, thanks for the follow. I think we'll take a break here because we're at the end now, Windows, and then we'll take like a 5 to 10, and then we're going to hop inside of Linux. So for those of you all following along, yeah, good job, everyone. This is a lot. This is a lot to cover. You've already covered a lot of ground. Like you've learned how to use Windows at a local administrative level. You've learned about processes, services, the registry, the kernel. We learned a ton of stuff. We learned how to administer Windows in the command line, create some scripts, install, remove applications. A ton. It's a lot covered. So you should feel good about yourselves. And now you can unlock a little resume bullet point. So go ahead, and when you're going through the course and when you feel comfortable with this, once you pass a module quiz and you feel good, then go and throw that on your resume. And you've now added a little resume bullet of Windows OS administration. So you've learned some things. Yeah. Very cool. MP signups, thanks for the follow. Yeah, DT. This is why you need to know this stuff exactly, is your attackers are going to use PowerShell on you. You need to learn how to fight back with PowerShell in scripting languages. And you need to be aware of the commands that they're running so that you know what's malicious. Because attackers are really crafty. They're not going to just leave little commands like this. They're gonna hide this. They're gonna put commands inside of other commands. They're gonna encrypt it. They're going to encode it. They're gonna hide them and make them hard to see.
Yeah, PowerShell's really good at deobfuscating itself too, though. If you can just put a print statement, if you've got a little block of obfuscated PowerShell or encoded PowerShell, you can
Yeah.
have it. You can just paste it into PowerShell and have it print the result.
Yep.
It's a quick way to to deobfuscate some things.
Yeah. Very cool. Good stuff. Okay, cool. Well, let's take a little break. Let's go stretch your legs, get up, refill the coffee. right. We're back in action. Cool. So Karina, so for the first PowerShell challenge, I see wasn't rested. Maybe resetting the value of edge value script. Yeah. Good troubleshooting. Yeah, cool. We won't walk through the challenges, by the way. So these challenges are for you to kind of work your way through. We've given you some starting points of what to do, but you're free to ask questions inside of the SOC 100 student Discord for general guidance, maybe some help trying to figure it out. But we want you to work through these challenges and learn to ask good questions, good documentation questions, and ask questions like, I don't really understand what this line is meaning or what it does. And you can use tools like the SS64 and some good Googling too to help figure it out. So make sure to give these a go. The challenges are optional, but they are very, very good for your development. I highly, highly recommend you go through them. Yeah, and honestly, yeah, ChatGPT is fine to use, not for the answer. So I'm glad, yeah, like Steven, it's good to use AI tools to help you understand things, and you can kind of ask questions for it on the fly. But just asking it for the answer is the same benefit as like taking out a calculator and saying what's like 30 times 5, instead of just kind of like knowing quickly in your head and letting yourself do the mental gymnastics. So good stuff. Cool. Okay, let's go ahead and let's jump into the Linux operating system. Now I'm going to go and turn off my Windows workstation. We won't need it inside of Linux. And we're not going to need it for the first 2 lecture slides as well too. So let's get my setup ready over here. So kind of like the Windows side, we're going to do a little bit of talking points first. Not going to spend forever, but just enough to be able to get a good sense of why Linux is, the benefits and purpose and value of it all. And it is important to understand it to some degree, excuse me, from a historical perspective, but also the architecture of it. It is quite different than Windows. So let's walk through it. In the meantime, oh, nice. We had Bilbo back. Bilbo has joined us. Bilbo is following. 5N and Sycamore as well too. Thanks for the follows. The fellowship has started. Good stuff. Okay. So we're going to start off with history and architecture now. Proprietary. I'm just going to minimize that. Kind of walk through a little bit of the timeline over here. But, okay. So Linux, effectively how this all began. This was in the 1980s over here. We had a gentleman by the name of Richard Stallman, software engineer, and started up what was called the Freedom Software Foundation, or rather Free Software Foundation, FSF. So now he started this up, and essentially what the purpose of this was to take a system called Unix, which was quite popular at the time. So Unix was a very popular operating system. This was around a lot earlier. Initial release date, yeah, in the 70s. Unix was an early operating system with the kernel and everything involved to utilize computer hardware. And it was under a very, very stiff license. So that meant a high cost. That meant a high barrier to entry. So we had this gentleman. Okay, Richard Stallman. I'm gonna go drop his link inside there. Little Linux history for you over there. What's so 5N saying isn't giving you a good search result recently after a lot of sites removed their open source API, prevent tool from scraping data, so make your own search tool might be more proficient. Even the good old Google Advanced Search is probably better at the moment. Yeah, so the thing with ChatGPT and these AI tools is they're not really ready yet to create things on the fly with their reference data. There's a lot of errors and there's a lot of AI hallucination. So if you're going to use ChatGPT for these types of exercises and to train yourself, you need to train the model. Like, you need to tell ChatGPT what it is for you and what it needs to be, and you need to give it reference data. Otherwise, you're going to see it does get quite inaccurate. Like, it'll probably tell you at some point that you can run commandlets of PowerShell inside of CMD. I bet. Like, just keep messing around with it. It'll tell you that at one point. It did for me. Like, I was trying to break this stuff before, and yeah, it'll hallucinate pretty quick. So you need to make sure that your reference data is good and don't overcomplicate your single chat with the GPT. But anyways, back over to Linux. Richard Stallman. So, founder of the free software movement, which eventually started this. This is kind of a key integral moment. This is the Free Software Foundation. And what he wanted to accomplish was create a free version of Unix as best as possible. And through a lot of trials and tribulations, he actually started to develop something called GNU. So you can take a look at this. Let's take a look at GNU. Let's put GNU Linux. It'll probably come up with a better... no, I guess not. There you go. Yeah. Dropping a couple articles for you to keep in chat over there for you to have some bedtime reading. But effectively, the GNU operating system or this GNU project was meant to provide a Unix-like operating system with a Unix-like kernel. And Richard Stallman and the team, without getting kind of too complicated and getting the weeds over here, it took some time to develop. It took a little too long. They were trying to do some advanced architecture, structure of the kernel, and some more advanced capabilities and features, which ended up taking a lot longer than anticipated. And what had happened during this time was a gentleman by the name of Linus Torvalds kind of came to the scene. And he started to develop a Linux kernel that was effectively as close to Unix as possible, but not the same. So it was able to take the Unix software that could run on Unix, but on a free and open source kernel, which is the Linux kernel. We talked about kernels inside the Windows side of things, and he got to the scene faster. And Linus went and he started to distribute the Linux kernel and this Linux operating system quite early on, sharing it around, asking for developers to contribute, people get involved, and it kind of caught on like wildfire really, really quick. And this notion of open source free software was born effectively through this time period, where someone could write their own kernel and then provide that kernel with tools and processes and building blocks to other developers to add operating system components onto it, like we've seen with the command line, the Windows GUI, which Linux kind of made their own version, which we're gonna see as well. These window managers appeared, printing services, you name it. Like all these additional components that make up your operating system were then developed by the community, and it took off really, really quickly. Now, that whole GNU side was also being developed in tandem, but it took a little bit later to develop, and all the tools that were able to work with GNU were also able to be working with Linux. And this is why the long and short of a very controversial naming history over here, people sort of settled with the general term of GNU Linux, because there's a lot of compatibility between the two, that these GNU-like tools, like you've seen with this bash shell and those commands like cd and dir and stuff, compatible kind of both ways. And because of that really changed the game landscape, because up until that point, we had the Unix operating system, which was held behind by academics and high cost of license in universities. The regular user wasn't really using it. And then we had the GNU side develop, didn't really take off until later. Linux came out, and all of a sudden, a bunch of people were able to start using this operating system. Now, at the same time, we also saw some other things happen inside the market. Windows was also in development too. They had MS-DOS, and Windows was able to provide something sort of similar in some ways to how the Unix world was working, but also some hybrid elements that allowed a very powerful native kind of Windows operating system with that window manager that we've all seen to date, dragging and dropping different types of windows around and such. Kind of like these tabs right up here, like this window manager. Windows really made something accessible and cheap, like compared to what you would see in the market. Now, Linux continued to be worked on because it was free, and that made it very popular. It was affordable, and not just that. If we kind of go through these slides, I'm kind of just like talking them over in my head here, but I think we get to that. I'll get to the file structure in a moment. But what made Linux quite popular is you could strip the Linux down to the Linux kernel and then add on just what you needed, and it was entirely free. Windows went with a different paradigm. They went with creating the Windows kernel, as we learned, and the Windows operating system components that you couldn't change, but was very stable. And this is why they built like the registry, and they built these components to all work together and work quite well, to be extensible and support a lot of different types of user use cases. And they optimized the use of kernel space and user space quite well. And they had this ability to work well with hardware compatibility and user needs. And that is effectively why Windows started to take off quite quickly around that time, because you could use it for server needs, corporate networks, etc. And it was easy for a user to hop on and just start using it. Whereas Linux, as you can see, right? I don't have it open anymore, but you saw, imagine instead of starting with the Windows GUI, you started with MS-DOS. Like imagine, because that's how I started way back one, but this was how you started using a computer once upon a time. It was just this. That wasn't very easy, as you can see with some of the command line stuff that we've been doing so far. It's not natively easy, right? Like you have to learn a lot of technical terms, and you have a lot of power over the operating system, which is dangerous. So Windows took off quite quickly for that. It was cheap enough. You could afford a license at home, a regular type of hardware, kind of like this, like something you could buy at home, which was still expensive, but something you could buy at home. And a Windows license meant you could start messing around with a pretty decent computer for your home needs and for developing and for gaming and office needs. But Linux was a free version of this, which obviously took time. It took time for Linux to start catching up, and it stayed in that state for quite a lot longer. It stayed very terminal heavy. The initial operating systems with some window managers were not as nice, not as easy to use. It still required a lot of technical expertise. So it kind of lagged behind in that way. Now, a lot of that has changed. Let's take a look at like these versions of Linux now. So let's take a look at this. That's a terrible image. One second. Okay, cool. This is Linux. So like this is what Linux has actually come and appeared to be now, which is, I mean, like if you look at it, like that kind of even looks like Mac, which we'll talk about Mac another day, but Mac's not Linux. It's actually more off of BSD, which it's another conversation. But you can see there's a lot of similarities. Even Linux has come a long way, and it didn't look like this at first. It looked very terminal heavy, which kind of, it wasn't easy to adopt, and it required a lot of maintenance. And there's a reason for that, because just as Linux, as I mentioned, was, you could strip it down to the Linux kernel and just get what you need. So you could have like a Linux operating system free for your printer, for some web servers, for controllers and like power plants and stuff that you don't have to pay for. That's amazing. So you can strip it down and make these individual things, and you can't do that with Windows. However, there is a general difference in the way that Linux works, in two kind of native levels. One being the file system, and two being the way that the kernel loads these processes and system calls back and forth between user space and kernel space. So I saw someone in the chat earlier on mention about kernel panic. Yes. So here's an example. For those of you that have Windows at home, when you're installing software or services, or even when you're at work and something changes, you have to restart, right? Like more often than not, there's like, please restart the computer now to finish operation, or like you run a Windows update. Okay, now restart Windows. You've all seen that. That is because of the design of Windows, the way that the kernel user space are isolated enough to prevent as much as possible those types of kernel issues, which reduces the speed of Windows in some ways. As a result, there's a bit of a trade-off. Linux is not like that. Linux has a lot more direct operation inside the kernel, which you can cause these kernel panics, and you can hang up Linux entirely as a result when you're trying to run these things. You have much more direct operation to load drivers, load modules, load things into the kernel space as a regular user compared to Windows. Windows actually blocks off quite a lot of that compared to how Linux does. So there's some structural differences that way. The file system is also quite different. So let's take a look at like the Linux file system. It's going to be a better chart for that. One of these. Yeah, cool. Sure. This one looks all right. That doesn't look good to read at all, though. You know, where was... Okay. I'm just going to zoom in on this because I actually kind of like that chart. I don't know where I found it before, but the Linux file system, as we've seen in Windows, that like structure of like C:\/ and directories, and then the Windows registry with this like giant database, this giant configuration database that everything kind of refers to. Linux doesn't have that. Linux has an entirely different file system, and it does not have a registry. And Linux is simpler. It is a simpler operating system. It is a simpler overall kernel and user space compared to Windows. Simple is good. Simple is nice, convenient, works well. You can strip it down, have what you need out of it. But as I mentioned, right, like there are some trade-offs in that. Like Windows is much more complex because it can provide a lot more granularity and support through this giant ecosystem of user and server needs all at once that is all kind of working together and more complex that you can't change as a result. Mac is very similar. Mac OS is this kind of walled garden that they call it. They kind of left off that Unix to BSD world, and they made their own version of an operating system, closed source like Windows did, that is also quite large and walled off, and it performs specific things, and it does it very well. And Linux doesn't go to that length. It is simpler and purpose-driven for what you need it to do. And the biggest reasons that it is now still in production essentially is it is free and extensible. You can't do that with Windows. You can't strip Windows down to just be a single thing for like a printer only. you still have to have Windows on there in some way. So Linux took off for that reason, like I said, and this file system supports that. This file system suggests that inside of Linux, everything is a file. Every single thing inside of Linux is a file. There is no registry. There's no giant database. The user up in chat before mentioning the kernel pack, they said they kind of deleted their lib64 stuff and their files. Cool. Go find it, find those missing files, put them back in the same directory. Everything's going to work just the same. Now, if you were to go and delete a portion of your registry in Windows, you probably wouldn't even be able to boot. This is why, like, some users are like, oh, I got to take my Mac over to Apple because, like, something screwed up so bad that you have to actually take it in for support unless you're, like, really, really technical. And Linux is not like that. Linux is just a giant list of files. So very, very different. And it just structures these files into different folders. We start from this root directory right above. And it's very, very logical and very simple. You can see this bin folder where your commands run, like cd, dir, like those binaries. That's what they're actually called. And binary just being a compiled level of code. They live inside there. So you'll always find them there. Kind of like how if you're a Mac user and your applications run inside the applications folder, same thing. Like it's just like this file that kind of lives there. You just drag and drop and boom, you're done. Windows isn't like that. Remember we saw in Windows how you have to install and you kind of click around and all this like configuration stuff happens for you. Linux it's on the command line, you just run a little package manager install and you're good to go. Mac, you just drag an application over. So very different. We also see how there's like a home user directory, a mount directory where your external drives appear, like USB drives. There's a root, like a system user level type of folder. And this is effectively it. All your configuration files can be found inside of the etc folder, like etc. So if you ever have like a configuration issue, cool, go take a look inside of etc. You'll probably find it there. And if you ever have a configuration issue with a single service or a single software, you just go straight to that folder, you fix that single config file, and you're good to go. Very different. Remember how we saw inside of like the Windows registry, right? Remember that whole like view? Because I closed my system, but like to get anywhere inside of Windows, you have to go through this giant registry of these hive keys, or sorry, handled key hives, where they have these like key values. It's very cryptic to read. It's very configured a certain way that you have to do a certain configuration for things to work. Whereas Linux, you'll just have like a config file with text inside, and you just go inside there and you update it and you're good to go. So very, very, very different. There is a notion over here to kind of take a look at the kernel towards the end of that video. I encourage you to read more. This is a deeper read. If you really want to see like the under the hood of the kernel, the Linux kernel versus like the Windows kernel, I encourage you to do some reading. Advanced for this time, but it's something for you to take a look into as you start wanting to learn more about this as well. But what you need to know at this point in time are two things. One, Windows does not have Linux does not have a registry. Two, in Linux, everything is a file. Every single thing is a file. Three, everything inside of Linux is at its heart text-based. Input out. It's all text-based. Those are the three immediate things that you need to know. And some history of how kind of Linux came to be and how it's taken over. Now, I showed you a picture of Gentoo Linux over here. And you can see there's a lot of Linux distros. Okay. And these are called distributions like Ubuntu, Debian, Arch, Fedora, Manjaro, Linux Mint. Like there's so many different types of Linux distributions and they all do different things. Like take a look at this website over here of Distro Watch. Oops, wrong one. That's the general chat. There we go. Why are there two root folders? So remember, it's actually pretty decent. Okay. So in Linux, there's actually the root user, and then there is the root directory drive. So the root, like the root drive of Linux is noted as a /, whereas Windows is assigned a drive letter of like C:\\. Now, you will have a root user folder on the root level drive for the root user. That's where like that is your power user. That's your system administrator, is the root user, effectively. So as you can see, like because of Linux being so modular, this website DistroWatch, you can see like all of these top used Linux distributions, these distros, and they're all different things. You might have heard of Kali. Probably you've heard of, oh, I like Kali Linux, like this hacker OS. Kali Linux is a flavor of Linux. It's a distro, and it comes pre-bundled with a bunch of tools dedicated to pen testing, red teaming, hacking. That's all it is. Yes, exactly, Stephen. So is a distro effectively just Linux with pre-installed software? Yes, that is it. That's all it is. It has a custom window manager, it has a custom set of tools built inside, whether that's for hacking, whether that's for forensics, whether that's for office administration, you name it. And then it has a name. You package all that together and it becomes a name. So you can see how like the OS operating type for Kali is actually Linux. It's actually based on Debian Linux. So you have Linux as the Linux kernel, Linux operating system, and then someone created the Debian version of that with their general level of tools. And then Kali was based off of Debian even further. So that's kind of the cool thing with Linux is you can keep using someone else's distro and modifying it to your needs and then just call it your own. So like Steven, you could make Steven Linux. Like if you really wanted, go and find Linux with a bunch of tools that you wanted and then make your own. So pretty cool. Yeah. Yeah, very cool. There's actually, so for you Mac users right now, Asahi Linux is really coming together. One second, I think James Cam is not working. 1 second. Yeah, I think he got frozen. Interesting. One second, I'm just gonna yeah, stop process. PID James. We'll get James set back up there in the meantime. But a couple follows in the meantime, and then I'll pause as well too. So Sekmore, Hitode, and Saka, thanks for the follows. But I'll pause there. So that's a lot to take in. And then I'll talk a little bit more on a couple more aspects of Linux when James gets back as well. Yeah, okay, James, I see your camera now. Let me add you back in. Yep, cool. You're live.
Cool. You can hear me now?
Yep.
Awesome.
Yeah, so interesting. Did that clarify some things for those of you that are like just hearing Linux? Does that maybe give you a bit of a higher level overview of what it is, why it came to be, some of the differences between Windows, some of the purposes as well too? You don't need to understand all of it at once, but generally, does that clarify and clear up some initial confusion?
Have you ever tried to build Linux from scratch? Xenofiles. Yes, I have put my own version of Arch Linux on my laptop, on my bare metal laptop. It was quite a learning experience. And while it technically has a GUI, I set it up to where you can only do anything in the command line. But yeah, it was really good to learn to set that up.
Amazing. So 5 minutes to talk about Linux. We got the Arch. That's that's what Zeno's saying. Zeno's probably Arch. There you go. Zeno uses Arch, by the way. So yeah, there's a bunch of like memes. I use Arch. So hold on, I use Arch, by the way, meme. So Arch Linux is like the most stripped down Linux. Like you get the Linux kernel and you just like configure everything from scratch. Super cool. Like you're gonna learn a ton. You can really optimize your system as well too. So there's like a bit of like a running meme you'll just hear. It's like, oh, like someone can't wait to say like I use Arch. Zeno, you got to do it. Yeah, it's basically like it's like showing off your stuff kind of thing. It's also a really good learning exercise. It'll take time. I remember configuring Arch as well too, like way back when it first started with stuff. I had no idea what the hell was going on. It took me hours to get a Wi-Fi driver working and getting wireless running. Holy hours. I had no idea what the hell I was doing. This was way back. Must have been, I think, like 7 years ago now. Yeah, 2017.
And good luck if you get it all the way up and running and forgot to install a browser or a command line, a way to access your command line. I did that the first time. I forgot to install a command line, a way to access it. So it's just sitting there with a blank GUI.
Yeah, it's cool. I mean, it shows you the power. Like you can't do that with Windows. You cannot do that with Mac. But with Linux, you can. You can strip it down to like the bare basics. And you can literally just build a Linux kernel with no internet, like no network access, and a text-based prompt for you to like type out your thoughts. If you really wanted to have like your own like personal diary environment. So pretty cool. Yeah. You will not need to be using Arch at first by any degree. We actually have you using XFCE Linux inside the course. So XFCE Linux. Super lightweight. Super lightweight. While also looks good. It's super light, but looks good. Like for like beginner users to get started. So that's why we gave you XFCE Linux. Inside the chat. Yeah, so 40H. The Arch install is easier mode these days. So on that note, okay, Arch Linux wiki. I tell students as well, you're going to find so much information on the Arch Linux wiki because of how much pain people went through. Because of the pain that people went through setting up Arch Linux, there's a ton of documentation that you could find on like general Linux support, like weird like kernel issues and module loading issues, mounting issues, driver dependency. Like there's so many things. Yeah, Gentoo is pretty good as well. I'm not sure if anyone's ever seen like Pop OS. I always tell students, like, if you're super new to this stuff, like super new, and if you like a Mac environment right out of the box, that everything kind of just works really well with good like driver support for video drivers, I always tell students, like, maybe check out Pop OS instead of Ubuntu. It's nice, it's snappy, it's got everything you kind of need right away for like a dev environment. It's an easy segue into it until you start getting into these deep OSs. But yeah, for those of you that are really into the Linux scene, there's a lot to follow, you know? So follow what you need. That's my advice.
Let's see a question. When you say lightweight, how do you mean in terms of the OSs? So Linux doesn't take up very many resources. So you can run it on a much tinier device. Like you could put Linux on a Arduino Feather, which is like this, or on a Raspberry Pi. But Windows, on the other hand, takes up a ton more resources and is a little bit more difficult to do.
Yeah. Yeah. Yeah, so Cap's doing that on a Raspberry Pi. Yeah, you can run Linux on a little Raspberry Pi, and you can set up like a little open source firewall on a Raspberry Pi and kind of gate your network. So a lot of cool little things you can do, all free, all open source. That's amazing if you think about it. Linux Mint. Mint is always up there. People love Mint, don't they? I never could get into Mint. I tried. Not my distro. I'm still a Debian fan, and I really like. Obviously, Kali's really good for my needs, but I really like just like a simple Debian Linux myself. Yeah, Mint is very like Windows XP-ish for sure. But it just feels dated. It has good support, like, don't get me wrong, but it feels too dated for me. Whereas Debian feels different enough, and it feels Linuxy. It feels like it's still trying to be Linux. That's what I like about it. And it's also pretty extensible, whereas like it's not as packed. Yeah, web dev for the last 20 years, but ran on Apple for a long time. Now I'm only on Arch 100%. Yeah, dropped Windows Dual just last year. Report. Yeah, nice. Yeah, so I live primarily on a Mac now, just because of the needs. I need to go back and forth between Windows, and having sort of like that compatibility without running to there's always going to be some kind of like Linux issue. So if you're trying to go into like Windows based things, it's a lot better nowadays, but like you're going to run into issues. So for my time that I need to be able to use an operating system for like dev environment from a Windows and Linux and Mac environment, content editing and such as well too. Like I do a lot of content editing and content development from like video production and stuff. It's easier for me to live on Mac as a result. And the integration between like my Mac OS and my iPhone, that I can kind of go back and forth, the ecosystem works well for me. So like those are my needs, you know. But that's the beauty of the initial days of Unix to so we went from Unix to GNU to Linux to BSD, then to Mac. Like there's a reason why those all kind of branch. It's for your own individual needs. Now, I am honestly debating switching to Asahi Linux on my Mac, because I haven't read up the latest updates, but it is actually really stable now, which is effectively Linux on Apple Silicon, which is huge, because Mac OS is pretty resource heavy, and if I can get my resources down, then I can make this MacBook like super. But yeah, a lot of chat stuff. DT, yeah. Mint is just, it just feels weird to me too. I agree with you, man. Yeah, my Windows box, so Hades, they are playing. My Windows system that I'm running right now is effectively just like, it is a gaming machine. And then if I need something powerful for like VMs and still living on x86 and stuff and x64, then I still use Windows. And if I need to run video content through like Adobe things that require a lot of resources, yeah, then I'll shove it through Windows with like my GPU. But that's effectively what it is for me. Starlight, what should I do? Wait, one about it. Late Ubuntu distro have restricted the hardware requirements. Not because Linux is going to run anymore. Well, 5N, I would just say, oh, really? Like the Linux kernel is restricting on hardware? I haven't read too much about that. What should I do to run Linux on my MacBook? You would need to run Asahi Linux, or you run a virtual machine. Stick with a virtual machine. You can go to VMware Fusion, which is now free, and you can download a Linux distribution. Oops, wrong one. I keep going to the wrong one. And go and load up like Ubuntu or Pop, one of the easier ones, and then work your way inside there. Yeah. Yeah, 40 hertz. Proton has been a game changer for compatibility layers. Yeah. Nice. What is it? Welcome first time chat, Alpine. Yeah, so DT, you swap between Windows and work. Yeah, exactly. And then you got Chrome OS. You got Kali on the side. So you're going to find like everyone's needs are a little different. Yeah, running, so 40, you're running into issues with CD and asymmetrical, yeah, CPU arch. Yeah. Yeah, I think if you can tweak and tune that, I'd be interested to kind of hear how you get that optimized. That'd be kind of cool. But yeah, I think that's a good enough like high level coverage of Linux, like I said. Now, the one thing that I want to talk about is yeah, so the next lecture is on software and shells. And this one's actually pretty important to cover because we're going to be talking about some differences on how Linux will work versus Windows. And there is a key difference. The first thing that I want to talk about with is the Unix philosophy and then daemons. No chart, huh? Okay, cool. Just go to the wiki then. Okay. So what do we got in chat? You mentioned editing with Adobe with Windows. Prin, yeah. So I mentioned Windows instead of, okay, so I do all of my stuff on Mac, but if there's something that I need that's really resource heavy, like Unreal Engine or some of the more resource hungry tools from the Adobe suite, then I'll throw it through my Windows machine that has like 64 gigs and a high-end GPU to process. But I can still live on Mac for everything else that I need. What's the main reason you can't emulate iOS in a Windows machine is architecture. So, so iOS. Architecture and licensing are going to be your two things that stop you from running iOS or Mac OS on Windows, one or both, depending on the version. It's 40 using task set. Yeah. Fair enough. Seems a lot to do with video editing too, but I got a Mac M1, seems to work fine, which is why I'm say resource heavy. Oh yeah, did that answer your question then? I see your second one over there, Prin. Try running Unreal Engine on your Mac M1. Try doing like motion graphics on it as well too. It's not bad, but it's kind of chunky. Nice. R double, you're using UTM? Man. I tried UTM on Mac a bunch of times. I ended up just going with VMware Fusion. UTM, I don't know, like it had a lot of errors. And it was slow. So I just decided to go over with VMware Fusion, just much more stable. I tried the Parallels trial as well too. Parallels is not bad on Mac, but it's expensive. So I didn't bother with that, but it's really, really fast. Parallels is like super optimized. Yeah, the M1 and that Rosetta layer. Like, I'm curious to see the M4s coming out. I actually do need to upgrade my Mac, and I think the M4s might be able to make Rosetta work better. Windows Starlight will not work on Mac anymore. It used to. Windows and Mac used to be very. There was things called like Hackintosh. Yeah, like you could make like a Windows out of your Mac. You could also put Mac on Windows through a thing called Boot Camp. Those days are gone. The compatibility is, people are still working on projects and you could dual boot, but the latest, greatest things are still really, really janky. I think for the amount of time that you're investing into it, you're probably better trying to earn some money to have like a low-end Mac and a high-end Windows, or a high-end Mac and a low-end Windows for what you need. Honestly, like the amount of time you're going to invest trying to troubleshoot with different software and compatibility and errors with the different architecture and version and licensing, I would say you could save your time and money by doing that. Like even if you needed to grab like a small part-time job on the side and then use that to fund it, like you're going to save more time. Those days are over. But I'm curious now with Windows now moving to an ARM-based architecture. We'll see. Things might change. And then, yeah, print, I have two different things. Cool. Okay, yeah, so let's talk a little bit more, and then I'm going to hand it over to James after that as well, too. So there's something that you all need to be aware of with the Linux world, and that's the Unix philosophy, which actually lived on into the Linux space. And the Unix philosophy, pretty extensive, like in terms of like what it was first saying. I like the more summarized version in 1994. This to me is just so much easier to understand. So I'm going to go with this one, and then we'll talk about the top. But effectively, what it's saying is, and this goes into Linux, is to write programs to do one thing and do it very, very well. You should also write programs to work together. And finally, write programs to handle text streams because it is a universal interface. This is why you see things in Linux and the Unix space, and even Mac under the hood. You can open up a Mac terminal and it still follows this. And even Mac to this day. You know why? That's why people are like, oh, that's a very like a Mac OS native type of app. And you'll notice that like when developers are writing Mac apps, they're all like tiny individual little purpose-driven things because of this Unix philosophy that has persisted. Like you'll have like a little Mac app just for like your daylight settings, for the little menu bar settings, for your clipboard settings. Like there's so many little ways to customize your Mac. Windows is not like that. Windows is like, oh, like here's one tool and then it's not compatible with anything else. It's just doing its own thing. Except for like the sysinternal suite, which we're going to learn about, to be fair. But like, for example, like the Unix philosophy, you could take like the ls command, pipe it to sort, pipe it to count. They all will work the same. Like they're all going to work off of one another's output, which we're going to see. All of the options, or flags as they're more called with the Linux binaries, those options and flags are also very similar, which we're going to see too. You would run like an ls tac a, so like the little hyphen to list all contents, and you'll see like tac a in other commands as well too. You'll see tac l in other commands. You'll see the same structure and flow between Linux commands shared amongst all of them, so that if you learn how to use a tool in one way, then it's probably going to help you learn another tool in a way. And that is very different. And that's what I was trying to talk about, like the PowerShell syntax. The PowerShell way of doing things is here's the PowerShell way to do it, and it's written in such a way that it is a one-time use of that verb-noun structure, like get process. And then as long as you live in PowerShell, things will sort of line up. But the moment you try to apply PowerShell-like things somewhere else, it's not going to work. But you can work in Bash, and you can work inside of Python and Ruby and JavaScript and even other programming languages and other shells, Z shell, and there's a lot of similarities because they're all sort of living off of that Unix philosophy. Whereas Windows is just like, YOLO, I'm going to do my own thing. So that's a bit of a gripe. That is a huge difference over there. But this Unix philosophy is what drives Linux to be what it is. So you will see individual tools for individual things. And that's a huge point to stress over here. Now, you're also going to learn about some differences between Linux and Windows, like services. Services are still background processes, but in Linux they're called daemons, and they have this little D. And a lot of this stuff is going to be more apparent as you start going through the hands-on material. You're also going to see this notion of package managers. And remember that in Linux, everything is a file. So instead of running an installer in Windows, you're going to run a package manager that'll just grab all the necessary files and things in Linux and put them in the right directories, and boom, you're good. No rebooting. Like I said, right? Like the difference between Windows and Linux, that Linux kernel interaction is much more involved as opposed to Windows. That's why the user space is always requiring you to reboot and then things are updating. Linux is just like, okay, update done, install this done, remove that done, and you can just keep going about your day. Whereas Windows is like, install this, reboot, uninstall this, reboot, change a service, reboot. There's a reason, is because of that user space, kernel space interaction. And package managers makes a different is a different environment to installing and removing software, as opposed to Windows installers, to emphasize that point. But cool. Okay. Another concept is the permissions. That's also a little bit different inside of Linux. We're going to be dealing with a command called sudo or sudo, depending on what you like. I have just settled on sudo myself. Some people say sudo. You're going to have, this is your first experience now. Welcome to the Linux world, where you're going to have divisions. You're going to have people saying you should use nano. You're going to have some people saying you should use vim. You're going to have some people saying it's sudo. You're going to have some people saying it's sudo. Welcome to Linux. I say this. As long as it's generally close enough to the intended design of whatever it was, you're not wrong. It's just tomato at that point. Now, super user do is, I guess, would technically be sudo, but sudo, just like rolls off the tongue easier. So I settle with sudo myself. But you're fine to say sudo. And then I say etc sudoers for the config file used for sudo permissions. So just go with what is easier for you in that regard. No one's gonna complain about that. Yeah, data, SQL, SQL. Yeah, there's a whole lot of that stuff. No one's really judging you that hard on it. They're probably just giving you a hard time. But anyways, permissions, like I said, are different inside of Linux because things are simpler. Remember, it's a simpler method of operating with data. As a result, whenever you need permissions inside of a Linux environment, it's not like Windows with like that administrative console and UAC and all those prompts and stuff that appear. Linux is just going to be like, hey, I just need to up and elevate my privilege temporarily with a sudo command that allows me to run something with elevated permissions or the intended permissions, which we'll learn about. It doesn't always mean like highest level. And that's it. So that's a big difference as well. And then the concept of shells is the last thing that I wanted to talk about, and then executables. So going back to the Unix philosophy, write programs to handle text streams because that is a universal interface. You will always find a way to hop on the command line in Linux to operate the system at its most efficient level. Always. The GUI is just for ease of someone who's not familiar or doesn't want to use the command line. But yeah. You will always find a way to operate with text and command line. So as a result, Linux is very shell heavy, and shells are these processes that provide you a text-based interpreted environment to interact, as we learned last week, with the kernel space as needed. So remember how I showed you can run like shutdown? Well, then you're effectively communicating directly to the kernel to shut down the hardware of the computer, bring the power state down. So the command line in this shell environment allows you to operate commands and operate with the operating system itself and other processes and other data and data streams, etc., directly. And Linux, the Unix philosophy, is intended for you to be able to do that. So by extension, you will find it much easier to operate Linux on the command line than you would find it to operate Windows on the command line because of that. And kind of going back to what we learned earlier with PowerShell, PowerShell has come a long way. It's made things easier if you develop and focus your time on PowerShell and become good with PowerShell for Windows needs. But let me stress that. It's for Windows needs. Remember, PowerShell is a .NET integrated and Active Directory and server and OS scripting language. So focus on PowerShell for those needs, because it's not going to translate beyond that too well. But in Linux, operating on a shell environment, the bash shell, which is kind of like the CMD, like the command prompt, means that you will naturally start to develop a better prowess and a better understanding and better grasp of what the Linux kernel is doing, the operating system itself, and you will have a better, deeper understanding of how you can defend your system and how it can be attacked as a result, because that is where your attackers are going to go. They will try to enter at a lower level than the GUI. They will try to get to that text-based layer as well. So there's a benefit. There's also another added benefit that the more you use Linux, I like to tell students when they first get started, it's kind of like the difference between those of us, like I grew up with a manual transmission. If you learned how to car, that's a new way to say it. If you learn how to drive with an automatic transmission, then you had a lot of things provided to you, right? Like you just turn the car on, it manages your engine for you. car.exe. If you learned how to drive manual, then you have to manually interact with the engine, right? Like you're changing your gears, you're interacting with the transmission, you're monitoring your RPM. Linux is just like that. Remember the kernel being the engine of your car? You will be directly involved with more insights into how the kernel or how that engine's running and how you can interact with it to get the best performance and really control it to your needs. Whereas Windows is a little bit more like an automatic car. It's intended to be like an automatic car. You kind of turn it on, and even Mac as well too. Turn it on, boom, kind of off you go, runs well, has everything you need. You don't have to worry about getting under the hood. Linux is not like that. You will have to get under the hood. That is my spiel. That is my long rant on getting started in Linux. And I think it's important to cover those concepts. It's a lot of talking, I know, but I hope that it, I guess, excites you and encourages you and gives you a deeper understanding of why Linux is the way that it is and how you can get a usage out of it. Any questions on all that? Because I need a drink of water. Nice, Abe. Yeah, I remember. Yeah, my first car was $1,000. It was an older used manual Nissan. Yeah, those are the good old days. CI, is this my favorite OS? I think overall, the Linux operating system and its ability of different distros for my different needs makes it overall my favorite operating system. But like for my needs, like if I just wanted to use a computer how I grew up with, like play games, mess around with things, hack it to do things that it shouldn't do, then yes, I would want to live inside of Linux. And it's almost fully there to be able to do that without requiring a lot of time of tinkering. I don't have as much time to tinker anymore. So I default back to Mac, so I don't have to tinker as much. I would say, yeah, Linux overall is my preferred and my favorite operating system. And throw me on Debian, and I'm quite happy with that. And if you could have gaming as good as it is on Windows and as easy as it is to manage on Windows and put that on a Linux environment, I wouldn't even be using Windows anymore myself. And then I use Mac for the compatibility and the ecosystem. So again, if you could take the Mac ecosystem and put that inside of Linux and just have it all integrated, great. So overall, it's my favorite, but it's not enough for me to use it primarily. What about you?
What about
James?
me? Yeah, I would say Linux is my favorite. I mean, if I go back 10 years ago and think about my computer usage compared to today, I didn't know what Linux was. But then I learned it, and now when I'm on Linux, if I have to touch my mouse, I'm annoyed. Like my hands never leave the keyboard. It's so much faster to just type in the command line and do anything you need to do. So yeah, like I would echo what Anthony said. Without games are still easier to play on Windows, but in general, I prefer Linux.
Yeah, I agree with you, 5N. Yeah, I agree. It's getting there. It's so close. Like Linux is getting closer and closer every day to being like I think it was 40 that mentioned Proton up above in chat. Yeah. Like the Proton layer for game support is huge. Like that's why like the Steam Deck, you can play games on like the Steam Deck inside of it. It is a Linux operating system. Super cool. And yeah, I like you said there, James, like And that's what you're going to notice too as students is like you're just going to live on the keyboard and you're going to be like, this is so much easier, so much faster for me to like get what I need done. The mouse, yeah, like you don't need it once you can start using the computer the way that you can on a keyboard.
Mice are like blasters, and a keyboard is a lightsaber. Mice are clumsy.
Yeah, they are. Yeah, I like that. Okay, so we'll do this. I'm going to pause here anyways, because we just kind of covered a lot of good lecture stuff. Yeah, I guess before we go, yeah, 5N. Yeah, so like the mouse is even starting to get outdated, and now it's just touch. And eventually we will get further and further away, and we will get to like biometrics, right? We're going to get to Ready Player One. That's kind of where things are going. But let's take a little fiber, let's take a little break, and then when we come back, James is going to hop on, and James is going to start, James is going to start walking you through Linux and getting you ready to go. So let's go ahead and do that. Exciting. All right. All right. Welcome back. Welcome back, everyone. Gonna set up James' screen over here. Hopefully everyone's taking a little bit of a nice break. Maybe grab a little cup of tea, some coffee, snack. All right. We got a couple new followers as well when we're back. Thomas and Edu Marie. Cool. Thanks for the follows. Nice. I think we gained like 25 followers today or something. Not bad. Okay, let me get you set up over here, James.
It's never too late for coffee.
That's right. Okay, you know what I'm going to do is I'm actually going to just crop out that. So you got like a nice little Linux environment for you over there. Cool. All right. I think you're off to the races then, James.
All right, looking good. All right, so we're going to talk about navigating the Linux GUI, the graphical user interface. So as Anthony mentioned earlier, this is the XFCE desktop environment. It's pretty slick, kind of minimalist, but as we go, you're going to notice some similarities with Windows that I think are going to help you feel a little bit more comfortable. All right, so we're going to take a look up here at the applications menu, which you can just get, just click on. And so it shows you the list of all the installed applications you can see right here. So we can just run those. We also got some games. So we got Solitaire and some Office stuff here. So yeah, we can just click on these and launch them. Launch Calc. There we go. And next to that, we've got some places. These are, it's kind of like File Explorer. So I can click on Home. So you'll notice it's pretty similar to File Explorer in Windows. So you can look at all your folders and files here. You can organize them either in a list or in icon view. Icon view here. And a list. So it's set up, as Anthony mentioned, it's files. Everything's a file in Linux. So we have folders and files. So you can kind of visualize in your mind going through this and just opening up folders. All right, so we have a trash can here. So I can take this test.txt file and move it to the trash from anywhere. Move that to the trash. And we can also recover files from the trash. Offers an undo button here. But there we go. So I can just take that. I can put it back on my desktop. And there we go. Pretty simple. And then we can also empty the trash if we click on it. And now it's gone. You'll also see, similar to like Windows, we have the close button here. We can make it bigger, can minimize it, and this is kind of like your icon tray down here at the bottom. Not too different, and that's by design.
Yeah, nice and easy.
All right, so we can check on some settings. Go over here to Applications, System Tools, and then we go down to Preferences, and we can see some system settings here. So we can look at all the way down here. We can go to About, and we can get some nice information about the system here. You can see that we have an IP address here. We've got some memory, just your standard system information. You can see that we're indeed running on Ubuntu. And we can also go up here in settings, up to network, and this is where you could set up a VPN or a proxy. So if we click on the plus here, we can see that it's got some default options if you wanted to set something like that up. And then we can use the search function too. So if I go up here and search, say I don't know, I'm in my settings, I don't know what I want or what I want is, but I want display. There we go. These are all the things related to displays. So we can set a resolution from this menu and everything like that. We can change it to portrait if we wanted to. We can even set in the search section here under settings, not the actual magnifying glass up here where we actually type in our search. But if we see down here, lost it, up there, the search. This, we can actually control what it will search. So if I don't want it to search in my files, I can tell it not to do that. OpenVPN comes pre-installed. That depends. Usually, I think it does, but it's Linux, so maybe. It depends on the distro. Alright, so here we can go over opening some applications. So we go back up to our applications menu if we want to open up an application. And we can see here there's a bunch of different stuff. If we go over to Internet, I can open up Firefox in a minute. Sometimes it takes a minute when it's the first time.
That's actually much faster though than it used to be.
Yeah.
Yeah.
So Firefox, pretty similar to Chrome. It's a web browser. You can just go about your browsing. And say you don't want to go, all the way down here every single time. You can also just drag it over here, and it'll add it to the desktop. All right, now we can go over and find and use the application finder up here. And here we can search for our application that we want to use. So if I wanted to open calc, here we go. Just hit enter. And there we go, we got our calc. How do I get to settings? Yeah, it's applications, system tools, preferences, and then settings right here.
Don't click on that link, whatever that is.
All right, so now we're going to go over, this is our home folder. As Anthony was talking about earlier, every user has a home directory. This is the same thing. This is our home directory here. And so we can create a folder. We'll say it. Test folder. Now we've got a test folder. Notice we're not inside the desktop here. The desktop is its own folder inside your home directory, and we created this in the home directory.
Yeah, so it's actually cutting off the stream title. I put it in the sandbox. I just don't open up random links on stream is what I meant for you, James, not the chat. But so it's actually cutting off analyst at a certain part. So let me just change that. Becoming a, you know what? Just becoming. You know what? I'm just going to put Cybersecurity Analyst A3. Let's just do that. So that goes. Sorry for the interruption there, but thank you, Girl Lazo, for the heads up. And thanks for the follow, too.
All right, so we created a test folder here inside our home directory. You can go into it, double clicking on it. So it's empty. And then we have a back. Say we want to go back to home. You can click on home if you want to, or you can just click this back arrow and get back to the previous folder. All right, so now we can just delete this. You can delete an entire folder. And you see here, I pointed out earlier, we also have the undo button. So if I just didn't mean to do that and want to yank it back, should. Did I miss it? Or we can do that. Let's try that again. Undo. There we go. Now it's back. We can also do things like see the properties. So we can see the name, the type. So it's called the. We also call folders directories, and we can see where it lives in the system. It lives in the home Ubuntu. So that's our username, is Ubuntu in this case. We can see permissions here. You can see that I am the user that owns the folder. I can create and delete files here. I'm a member of this group. I can access these files. Basically, I have full permissions. And you can change the permissions. So I can make it so that I can't even delete the file.
So yeah, you know, chat, remember from Windows when we were covering it, right? Like, do you remember how much more complex the Windows security permissions structure was with the tab? And you can see inside of Windows, there is like a granular level to get security permissions as well as inheritance. Remember we talked about disabling inheritance and all that good stuff. You can see just how much more like robust, like Windows is kind of prepared right away to make that user administration, sharing, and permission setting a lot more dependent for your needs. It goes much deeper. Whereas this is another emphasis about how Linux is just simpler, right? Like there's just like that read, write, execute level of ability which we'll see more and more, especially as we get under the hood.
Absolutely. All right, so we can delete this here, and it's always good to clean up your folders. Otherwise, before you know it, you'll look at all your folders and suddenly you've got 100 of them, and you don't know what's in each one. So when you're done with it, you can just delete it, empty the trash. Just keep a clean workspace. And so yeah, I mean, Linux GUI is it's pretty intuitive. It's not, it's not so scary, right?
Yeah. Like I like the XFCE desktop. I mean, I wouldn't like personally use it for my day-to-day Linux OS kind of GUI if I needed to or wanted to, but like it's super lightweight. Like everyone can see that inside of chat. Like it's simple to the point, it's performant, and this is a really good example of how extensible Linux can really be. Like you can strip it down to a very simple level like this, and it just gets the job done for what you need. Yeah, super cool. We're going to be getting to invisible passwords. James is going to take you there soon. I think we should hit the command line by at least by the start of it today. Yeah.
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 All right, so we talked about everything is a file in here. So if I want to go and see my root directory, the very lowest level, you can go down here, other locations, and click on the computer, and here we are. This is the root directory. This is where all the base files live. So I can go into bin. We can see the once this loads, we can see all of the binary executables and system commands that all the users can use. Here we go. See the post command. We can go to etc, etc. And we can see this holds like configuration files for the whole system. So this is like in Windows you have system32. This is all the config files. And we can dig down into these. Maybe.
Question over there, CI. So what is the boot folder? Boot folder, I think we're going to get to the proc folder soon, where we're going to show how like everything actually is a file. But the boot folder is essentially this like similar. Like we have this boot folder for boot related config and resource information that are all files that we can look at, like kernel, memory, etc., like loaders. You're going to see that soon. But that's effectively what the boot folder is. Linux is simple, remember? So if we have a boot folder, we're typically going to expect to see boot-related information inside there as files. You can probably actually pull that up.
The boot folder?
Yeah, I guess you might as well. Kind of see what's poking around inside there. I think she's talking about the root.
Oh yeah.
Yeah, there you go. 2 up. Yeah, so maybe just grab like, is there anything that there says like kernel or whatever? some kind of like configure INF file. I'm sure we can open up something.
Yeah.
Yeah.
Yeah, so we got some information here.
Yeah.
But yeah, this just goes to show you too that like if you're looking in the GUI, you want to open it up, everything's a file. I just opened that up in a text editor. Okay. So yeah, boot folder. We also have the user folder. It's going to contain like libraries, user-related programs, shares. We can go to user and bin. And this stores just some more common executables. So yeah, these are things that you can run in the command line that most anybody can run on the system. We've got the, gotta go back one more. Bar down here. This is going to store like variable data, logs, temporary files. So here's the temporary folder. This is just stuff that gets created and deleted. Going to see a Linux focused course one day. Hope so.
Yeah, I think this module gets pretty deep. Like once we start getting to the command line with like variables and command redirection and data streams, etc. But like a proper like defensive Linux course, I think would be super cool.
For sure.
Yeah.
So this is dev. So this is where devices. So Linux, everything's a file, even your keyboard. It reads them. It holds them as files. So this is where all the devices on the system live, which is pretty cool. And we've got home. This is where all the users' home directories live. If we had another user test, they'd have their own home directory. This is our home directory. So look, now we're back in home, right where we started. We have mount. This is where you can mount other file systems, mount and unmount file systems. If you get something like that, stick it in there, and that's where it lives. We have opt, which is optional, right? Optional software packages that aren't like standard. So we have OpenCTI, Container Nerd here. What that is.
Yeah, we configured OpenCTI on this box to be able to be run for cyber threat intelligence. So something to look forward to, using a threat intelligence sharing platform.
Nice.
It might take a little bit to load.
Yeah.
Yeah, does it? But I think that's a good demonstration to show, because once we start hopping in the command line, like it's just so much easier to navigate through all this. We're just trying to show you, like in general, right? Here's a GUI. It's very similar to Windows. For those of you that are brand new to Linux, you could hop from Windows over to here, right? It's a matter of clicking around.
Yep. Here's a good one. Proc. So this holds. This is a virtual file system. So this holds the information about running processes on the system. What's a good one to look at here? You can see version.
Yeah, version would be good.
Yeah. So look, we got this version. So this is
that's
kind of like
yeah.
Sorry, go ahead, Anthony.
I was going to say, if you want to like zoom in a little bit, just because it's kind of, I think that text is kind of small to really kind of put the point home. I'm actually not sure how to zoom in on text editor myself, though.
Yeah, maybe control scroll wheel is not working.
View, maybe. Yeah, there you go. No? Yeah.
No, it didn't help at all. Uh-oh.
Did it go past the window?
I can't use my keyboard hotkeys, yeah, because it's in the browser. I can't use my hotkeys to get out of it.
Oh, wait, there it is, yeah.
There we go, okay. All right.
Yeah, Tam, we'll be getting to Vim and all that stuff.
Yeah, Alt F4.
I'm surprised you can't change the zoom on that. Like even like Control Plus or like Control Shift Plus or anything. We're not going to spend too much longer inside of text editor, but yeah, right. Like it should be able to just zoom in. I'm going to load up my Linux too and take a look. What's going on over there?
Here we go. How does it work? Well, it works in preferences.
Yeah.
Let's change that to. Here we go.
Nice. Yeah, there we go. Better. Okay, good. Yeah, I wanted you to sort of, I think this is a good demonstration to show, like, we're going to get there in the command line, but how everything is a file and how everything's stored in text inside of Linux.
Yes. All right, and then one more important one to go through is the root directory. So I know we are in the root directory right now, the /root directory, but we also have a directory inside there called root. And this is the home directory for the root user. But it's an 800. If that makes sense. It's a little counterintuitive. Or it can be, I can see. And also, you notice this little X here? Correct me if I'm wrong, Anthony, but I believe that means that you can't access that folder without elevated permissions.
Right. Yeah, we have a permission block over there.
Yeah.
So kind of like a little flag compared to what you would see inside of Windows.
Yeah. So that would be something you'd need probably sudo to do. Not sure if it'll let me since I'm already an administrator.
Are you trying to get inside the folder?
Yeah, I was just seeing if it would load, just giving it a second.
Yeah.
Yeah, so Linux uses like pretty strict permissions to control who can access which files. Like I can have a folder with a bunch of files in it that everyone can access, but I can tell them that they can't access one specific file, or maybe I just want them to execute the files but not actually be able to modify them. So you can pretty easily control permissions at a pretty granular level.
It didn't like that request. Just let it load in the background for now. We can move on.
Yeah. See if it ever opens up.
Yeah.
All right. So yeah, navigating the Linux file system, it seems a little complicated, but it's actually pretty logical. And I would recommend you just try to keep a mental map of where you're at in relation to both the root directory and in relation to your home directory. And I think that would eventually it'll be more intuitive. But yeah, it's just folders inside of folders.
Yeah. Folders inside of folders, files inside those folders. That's literally it.
Take a drink.
Yeah, I wonder. So, based on what you've seen so far, some of the students in chat, I know this is your first experience with Linux, so we're kind of easing it into you. Are you happy there's no registry that you have to look at? That's a question. Yeah.
All right, We're about to move on to the next section probably here. Does anybody have any other questions about what we just went over?
Yeah, so we just finished up, which lab was that? That was interacting with applications. Everything's a file? Yeah, okay.
Mm-hmm.
Yeah, cool. So now we're moving on to lab system monitor.
Yep, we're going to talk about system monitor here. Remember where it was. Can't remember where it was. Search for it. Here we go.
Yeah.
All right, we got system monitor up now. Might look a little overwhelming at first, but it shows a lot of real-time information. So this provides you some insight into the system's current state, what's going on, the things that are running on the system. Processes, CPU, memory, disk usage. So this makes it a little bit easier to troubleshoot. So right now we're in the process tab. And we can see that, these are all the active processes. You can see CPU usage, you can see memory usage, disk usage. We can go over here to the resources. And we can see charts. This is pretty much the task manager in Windows, right? You can see a graph of the resources in use right now. Makes it just a little bit easier to digest. You can see whoa, CPU's usage is pretty high. I wonder if that's because this is still trying to open.
It's still spinning. Yeah. it didn't like that.
No, I'm just gonna close it.
That's funny.
Let's see if this goes down now. Yeah, it's starting to go down. Maybe not. All right, but this is just some real-time information on the resource usage on the machine. We can look at file systems. We can see the available space and how much is used.
Yeah, we're actually going to get to kill-9 soon on the command line. Love a good kill-9.
Alright, so yeah, this is just a snapshot of the disk usage. Here, open it up, opens up the File Explorer. And this is listed by device. So there's dev. So this is the root file system as a device.
Yeah. So that's interesting to even highlight to the students to like physically see, right? Your disk, right? See that disk over there, that file system here is actually stored, like it's referenceable from the dev directory. You can actually get to your disk from there and manage it further. Very different from the level of interactability you can get from Windows. Like when we were in Windows and we opened up File Explorer, you saw the like this PC, the C drive, you had to click on, but you didn't actually physically see like where it was referenced on disk as an actual file itself that could be called upon and have different interaction with different configs. So like with the Windows space, we had to go and look under the hood and get under the registry. You could go even deeper inside of system settings, but again, from Linux, like it's right there to interact with for that level of simplicity. I love highlighting that because like as you go through it and you start using Linux side by side with Windows, you're like, wow, that's so much easier, so much simpler. So I hope that students keep seeing that as well.
Yeah. So so this monitor allows us to monitor the processes in real time. So if I go over to accessories and I open up mousepad. I open up mousepad, I can use it, and then we can find it. There we go. You can see it. And if I right click on it, click on it and select properties, you can see information about the running about mousepad, what it's using on the system, control group. Let's see if I can expand this a little bit. Here we go. Yeah, information about what users opening it. Pretty slick.
Mm-hmm.
And then you can also stop the process from running. You get a big warning here, stop process. And now if I go over here and try to click and type, I can't because it's stopped. It can't do anything right now. And then if I continue it.
Yeah, that's important to note over there. You can actually see like the input that James was putting in, just because the process was stopped, that data has to go somewhere. Like the kernel's waiting to handle that and put that in sort of like the right process, the right state, and it's directed to the mousepad process. So it kind of waits in memory. And then when James restarts the process, you'll see it. Like whatever he's typing there is invisible, but that data has to go somewhere, that input from the keyboard all the way to the hardware, to the kernel itself.
Mm-hmm. We can also just kill it if we wanted to.
Yeah.
And here we go. And that's shuts it off. So yeah, System Monitor is really good to handle like bottlenecks, crashes, performance issues. You've got an overview here to see what's going on in your system, what's using up resources, and you can address that if it's a problem. Yeah, knowing how to use System Monitor is going to make you really good as an administrator. It lets you see what's happening on your system. People complain their computer's slow and they don't know why. This is how you identify that and how you address that. Cool.
Nice. That was the end of that one, right?
Yep. Move on to system logs next. Go to Applications, System Tools, and then Logs. Thought I clicked it. There we go. All right, so Log Viewer is how you can understand events that are happening on your system. Application activity, errors, it usually gets logged. And that can help you identify issues in case you're not looking at it in real time. So here we go. Let's see. Going on there. So these are the important ones. You can see all the logs. We can see, applications, systems, security logs if we wanted to. This is everything. Bit of a text wall. So we want to, not always do that. So application logs is going to be details about software on the system. Use it to monitor the activities. Applications are starting and stopping correctly. We want to see that. We can look for errors, anything like that. And then system logs are more like kernel messages. Boot up procedures, authentication attempts are logged over here. So if something generates an error, we can probably find it in the logs. Or even if it doesn't, if something happened, successfully, or if it failed. Use processes to find a program on the system. Yes. Yep, you can look at the system monitor and see the processes that are running on the system.
Mm-hmm.
All right, so security is also going to show us firewall attempts or firewall activity, unauthorized access attempts. There we go. Something succeeded. Some background process doing something, logging it. Did that just load like a bunch of stuff? No. Okay. All right, now we're on hardware logs. Physical issues with devices connected connected devices get logged in here. Something's disconnecting repeatedly. Maybe you have a loose cable or something. You can see that. And so that we can also search for specific information. Say I want to search for root. Here we go. We have that in the hardware logs about security. Here we go. Session closed for user root. Something to do with cron there. Possible to explain how to read the logs? Would that be in a different live? Yeah, I mean, you can see, you can find a good one. So yeah, you can kind of see what's going on. So we can see that root was running a command, change directories, and also doing this for a cron hourly. So those cron jobs are like scheduled tasks. So they're going to run at an interval. So this looks like just something that was happening in the back end.
Yeah.
You should also be able to find the command line to generate some activity.
I know, like going through this, like it's just like, oh, I just want to get back to the command line. But I think you can see some of the applications that we opened up, right? Like text editor. Close that up. Search for get it, I think, or mouse. Yeah. Search for just get it if you opened up text manager. Yeah, there you go. Okay.
So we've got the UID.
Mm-hmm.
Activated service. There we go. We can see I made a test.txt. Mm-hmm. And don't know if it'll show me deleting it or not here. No, because this is just get it.
Yeah. I think you can double click it from here. Yeah, I get like a little bit more, can read it from there, right? So these are application logs in this case, where we can see that James opened up the get it process, which is actually the process for text manager, or text editor, I should say. and James interacted with the test.txt file on the desktop. So straightforward. Event logs from a Linux perspective are really like to the point. Cool.
Yep. Nice. So yeah, we could. Oh, I guess we just kind of showed text editor how it appears in logs. Yeah, you can use system logs to diagnose and resolve issues. You just need to know how to understand how to search, how to interpret, how to read these things, and then it'll give you a little bit deeper insight as to what happened if it's not currently happening. And then you can do some more advanced tasks like aggregate your logs using a tool, and then you can simplify, centralize everything, make it a little bit more simpler to you. And yeah, just try to get comfortable with the log management. It's a really good skill to have if you're an admin, or even if, just in general. It's good to know where to look to find this stuff.
You got a question over there, James. The fellowship inquires.
How do you remember what everything stands for? Repetition. And like Anthony was saying earlier, if you do go into the command line and type like ls, I always think of it as list stuff, but the L is typically like going to list something. So it's a mix of repetition and the fact that syntax is generally kind of standardized for the most part across different programs.
Yeah, remember the Unix philosophy, right? That you should have individual purpose-driven tools, but also that they should be able to work with one another. And this is that's what James is alluding, like the more you use Linux, the more you use its operating system, the command line, the tools, the applications, etc., it all reinforces itself every single time you're using it. You just get better and better with it. Whereas that's a bit of a disconnect with the Windows side, is a lot of it is just like general reading, documentation, understanding it, and then remembering. One of the challenges in the Linux module at the end of it is literally just to use Linux for 1 week. Just use it. That's what KS is saying. Literally just use Linux for one week for everything. So that's hard.
Yep, but it gets a lot faster. You might, be a little bit slow at first, but
yeah,
you'll build up the muscle memory pretty quickly. All right, I think we're good to move on to Task Manager.
Nice. Edu, yeah. Edu tried out Linux 5 months ago, has not been back into Windows since. Yeah. it happens. Yeah, as soon as you learn it, you're like, oh, I wish Windows was so much more like this. Yeah.
All right, so we're moving on to Task Manager. So this is a little bit of a simpler version of System Monitor. So it's a good tool for quick diagnostics. Use it to see which processes are running, and the resource usage, identify changes in real time. It's a little bit simpler than System Monitor, but sometimes you just want to take a quick look and see what's going on. See resource usage right up here at a glance, some processes, what they're doing. Nice little color coding here. This is that blinking yellow is changing. We know that right here, red terminating, green starting. Nice simple view here. So if I open up text editor here, I don't know why I go to mousepad. Let's go to text editor. I think we missed it. this over here. There we go. You see that flash of green there? We have text editor. I think it's this gedit, right?
Yeah, I get it.
Yeah. All right, so if we watch that and then I close this, and turn red. There it goes. So we can see what things are doing in real time here. Okay, color system. So yeah, if a process has taken a long time to start, you can kind of tell that here too. So then we can also use text editor here. There we go. See this application service? Got a good look at it at that time. See it starting up. We can also terminate things just like we did in the process or in the system monitor. We can kill it, terminate it. It dies. So one important distinction is that the task manager doesn't really give you the same depth of information as system monitor. It's usually faster for like quick checks, quick look at what you need to look at, or maybe see something that stands out unusual, or you can terminate programs using this. It's just a little bit quicker. Yeah, it's just a nice little quick way to not have to dig through all of system monitor if you want to do something and you know what you want to do right away.
Yeah.
Anything to add, Anthony, before I close it?
I think that's the last bit to cover for like GUI based stuff, right?
Mm-hmm.
Yeah, that was lab, task manager. Yeah, so effectively, the reason why we start off just showing the GUI moving from Windows first to Linux is to ease the transition into it instead of just throwing you in the command line right away, so that you can actually just use the operating system at first, use the tools built in, and you can see that a window manager like this and an actual GUI like the XFCE desktop environment, this is enough that anyone who doesn't even know the command line can still use Linux. And that's what we want you to be able to do, is hop over here, start off in this land, and then we're going to move over to the command line from here on out. So Hades, you got a question.
Reprocesses a file, but what happens when I set the proc folder to read only and not write?
I've never done that myself. I'm going to wager...
there are probably something in place to allow it to still be accessed, right?
Yeah, I don't know. There might be a higher level permission blocking that. I would imagine that if you were able to successfully do that, that you would run into a kernel panic, or the process or the operating system would hang up. Like you'd actually have crashes. Because remember that the proc folder, right, is that it's like a virtual file system that stores files for every process running. Like when James opened up Gedit, and the PID of Gedit, if you open that up right now, you can see, and then you go inside of the proc folder, you will find the Gedit process inside there based on its PID. If you were to make it read-only, then that means that the Linux operating system would not be able to make changes to processes that are running. So effectively, things would freeze or things would crash I've never tried to do that myself. That would be my understanding of it, unless there's another permission here that's even preventing you from doing that.
Yeah, probably shouldn't try it though. Might fork the system.
Yeah. Yeah, I would imagine that the VM would hang up itself at that point and probably run into some type of like kernel panic. A good question.
Yeah.
I've never even like thought to do that. Now I want to know what happens. Like I you know what? I might actually just like do that in the background while you're running through things, James. Brohart, welcome. Cheers. Happy Saturday. Yep, curiosity certainly sparked. I must break proc. Yeah, good question on the registry counterpart. Good job, Karina. So yeah, yes, it is a file or a set of files. You will find a ton of config files. Look inside of the etc directory inside of your VM. Go to etc and you'll see /etc. You'll see a ton of config related files inside there. And you'll also see individual config files for certain software and certain other things in the file system itself.
Cool.
So yes, now welcome to the command line. We're gonna have to get that zoomed in a little bit, I bet.
Yeah.
While you're doing that, I'm gonna go break my proc folder and see what happens.
This was work. Oh, I was using Terminator last night. We checked it.
Yeah, let's just use the GNOME terminal for now.
Okay. It's not letting me zoom in. It was
No?
no. I mean, I might be able to do it another way.
Yeah, hold Control Shift plus.
Oh, yeah.
There you go. Nice.
Large enough?
I think so. Yeah, that's good.
Cool.
Really get the commands out across.
Yeah, so this is the command line. This is where we live. You can use multiple terminals if you want to. This button. Yeah. Of course, it's going to reset it every time. All right. Now I've got multiple tabs open. Oh wow! This is. You do it again on me. Okay. Gotta resize every tab real quick. There we go. So each one of these is a terminal window. We can do anything we want. So I can do ls in this one. And I can go over here and do current working directory. And I can test. So we can run commands in each one of these independently. So yeah, this just shows that you can keep multiple sessions running at the same time. You can normally hit Control-Alt+T to open a new one. I don't know if it's going to do that since this is in a browser.
Try it out. It should, yeah.
Yeah, it does. Okay. I'm traumatized. I hit Control-Shift-W last night and it closed my entire browser. So yeah, we can open up a new terminal window with Control-Shift-T. Control-Alt-T, I mean. And then we can also go over here to these terminals if we want to close them. And that closes it. See, now I got two open. Now back down to one. Same thing here. So we can quickly just, Control-Alt-T, open up a new one. maybe ls or whatever you need to do. You know, cat test, and then you can exit. So you can bring up new terminals, drop them as needed. It gets to be pretty quick. So I can dock these. Do another new window. You do that up there too. Size it a bit here. This is another way you can do it. So you can see here now I've got same two terminals, but now I can see both of them at the same time, and I can switch between them. And I can also do things like so I just wrote hello into a test file, and then if I go over to this other terminal, my cat text, it's in there. So you know they're managing the same stuff. How am I zooming again? It's Control-Shift+. Yeah, and then you need to keep hitting plus. So every time you hit plus, it increases the size by one like increment, and then you can also, I believe, hit Control-Shift- to go down. Freeze on.
Yeah, I just tried to get myself into the proc folder and remove Xcupid off of all of it. Some of it got removed, some of the basic things, but I just kept getting permission denied. So because it's a kernel, it's a virtual file system, right? Like it doesn't behave like normal files. It's virtual. It doesn't really like live on disk. Memory managed. It's within the kernel. So I was curious. I was wondering if I would have that extensibility, but no. Hades is appealing to the pen tester in me. Can't help it. We've got a couple follows here too, James, in the meantime, when you're setting that up. House, Rawl, Jab, Roberton, and Brohart, TTV. Thanks for the follows, everyone.
Yeah, thanks, guys.
Yep.
All right, so someone asked, is there a keystroke to switch between the terminals if you're on the level effect VM? That I'm not sure of, because like I said, running in the browser gets spotty with the keystrokes. So normally I think it's Control-Alt-right arrow to switch between terminals. No? Whoop. What just happened?
What'd you do?
I don't know, they just closed. Bring these back up here.
Oh, yeah, maybe that's what you did. You might have switched desktop spaces with the shortcut. See in the bottom right?
Oh, yeah.
Yeah. Go that left one. Click on the mouse button on the left one. On the bottom right.
Oh, bottom right?
Yeah, I see the little...
no, my webcam's in the way.
Oh,
that's
yeah. Yeah.
Oh, okay.
Yeah, go to the left one, left space. It's kind of like how Mac is. Yeah, there you go.
Yeah,
okay,
so,
you hit a shortcut.
Yeah, so Control-Alt-right arrow switches, yeah, your desktop.
Yeah.
That's good to know. Oh, you might be able to see here. We can right-click in the window there and go to Preferences, and we can see some shortcuts. So new tab, new window. We got some nifty shortcuts here. Looking for tab. Switch to the previous tab. So we can switch tabs for sure. As far as switching between the windowed ones, let's see what Control Page Up does. Yeah, don't recommend Shift Control W in the browser for sure. Let's see if that works. Now I've got 2 tabs open. Doesn't override the system.
Yeah.
So I tried to go into the preferences and re-hotkey it to Control Alt Right, and it still seems to switch desktops. It's good to know. But
Desktop
yeah, you can
shortcut first. Yeah.
Yeah. So yeah, so the terminal is more than just like executing commands. It's about doing things efficiently, quickly. I mean, you don't have to take your hands off the keyboard if you get good enough on the command line. Rarely. Usually only if I have to go into the browser, and even then I'm still doing mostly keyboard stuff. Yeah, working on this, learning, how to operate in the command line effectively is really going to help you.
Let's see what we got left on this one. We're coming up to 2. So that's the lab, the terminal, right?
Mm-hmm.
Cool. I think we can get through the command line interface lab, and then I would probably be enough. So talking about like the relative paths, kind of just running through all those commands over there.
Sure.
Yeah. Yeah. So House, we'll be introducing you to some more advanced terminals a little bit later, Terminator and even TMUX, like for multiplexing. But right now, this is honestly the first time quite a few of the students in this room have just hopped on the Linux command line. It's like the first time seeing like a GNOME terminal. So we're gonna take our time. We're gonna work our way up, but we'll show you some more advanced terminal tricks later on once we get some more proficiency.
Yeah, and on that note, is everybody still tracking? Everything makes sense so far? Do I work from home? Yes.
That's right, bro. They're gonna fall in love soon. It happens every time. Once students start going through Linux, they're like, "Oh, this is so nice." Yeah, so let's fire through some commands.
All right. So first command, we need to know who we are, so we can ask, "Who am I?" And it tells me my username. You can see it, and we know that it's also right here. But this, gives us a confirmation of who we are. So if I run sudo who am I, for example, now it thinks I'm root because it's the super user command. So that's a nice little distinction there. And we can do who am I and see what groups we have access to. Oops. Attack groups.
Listen, bro, we just asked sudo who am I. Sometimes we need to know if we're root. We're just showing the permission context change right there. How when you run sudo, it changes the context of your username.
He says nobody ever asked sudo how am I.
Yeah. That's a bigger question as well. I don't know.
All right. Yeah, it's just groups, duh. So okay, so we can see what groups am I a part of. These groups, denoted by a space here. And then groups, group. So I can also check my user ID. I do ID. So I'm user ID 1000. And then sudo ID, same thing. It's going to tell me root's always UID 0. It's the first user. The highest privileged user is always UID 0. And there are some non-user entities, non-user users, if that makes sense, on the system that also have a UID. So yeah, the UID, if we were to create a user, the new user's UID would definitely not be one that's already in use. What is touch this? The touch command is, oh.
No,
sorry,
that's just, yeah, that's just me messing around. What is touch this? Yeah.
So we can also clear the terminal like Anthony showed you with PowerShell. Control L. Here's the terminal. Pretty handy. You can also do CLS. No, you can't.
No, just clear on this one.
Yeah.
And then Control L.
So clear and Control L. We can see where we're at by print. PWD stands for print working directory. So you can remember it like that. And we can find that we're in the home Ubuntu folder. We can list stuff with ls. That's how I remember that one. And you can list stuff and then tack la to list all to get a little bit more information on the files in your current directory. So this shows you what permissions the file has, shows you who owns it, the group, shows you the file size in kilobytes, the date it was modified for each file. And then you'll also notice that when I did ls, we saw just 3, 6, 9, 10, 11 things. But when I do LA, we see way more stuff. So these things that are preceded by a period don't show up when you just do ls. But when you list all, you actually see that the hidden files here. It's good to note if you want to see everything in the folder.
We should pause right there real quick. Just make sure everyone's tracking with those that like ls tech al and stuff. That's always a huge sticking point for students first when they first see like flags being used and the tack line. Is anyone unclear when James is running? Put inside the chat over there. ls tack al. Like is anyone unclear like how that's actually functioning? Why we're saying tack and lart? Yeah. Why are we saying these things?
Folders are blue when they are directories, and the white one is a file. So that test right there, if I run the file command on it, we see it's just a text file. Whereas if I do file desktop, you can see it's a directory.
Yeah, so those flags, they change the functionality of the binary of that command. They're effectively adding or removing certain levels of output for us to work with on the terminal, the more or less you add in them in different ways. And that's important to remember, because ls versus ls tack al or lart above, like you can run like very, very different outputs.
Do LAH, yeah.
Yeah, we're going to get to the man pages in a second there, Zeno, yeah. I think that's the next step, right? We talk about the man page?
We can. Yeah, I was going to go with the CD, go with man page. Yeah, so you can do manual, right? So I can do man ls. And we can see this is the manual for ls. This is everything it can do. It's option and then a file argument. So that's where we see the tack LA, and then the file is where we can specify a different directory or we can go up or down just with this command without changing directories and see the things in other directories, as long as you have permission.
Yeah.
So you can see all the
ton of modification abilities here, right?
Yeah. Yep.
Let's go through Brohart's. Go and walk through the Lart.
Okay, so yeah,
the art of Lart.
A. Yeah. So we have the A. That's going to be do not ignore files starting with period, like I said. So those hidden files it's going to show. And then you've got there's the L, long listing format. That's why we're seeing the all the file size and everything like that. And we've got R to reverse the order while you sort it. And T to sort by the most recent modified files.
Pretty handy. And
you'll notice that also that when you do tac LART, you don't have to do tac T, tac L, tac A, tac R. It accepts all those, with just the one options.
Yeah.
With just the one hyphen.
You should actually, you know what? You should show that. Like do ls trowel, like do it backwards.
So there we go. Now we see, as we said, we can see them in long listed format. We see all the hidden things, and we see the modified dates, most recent first.
So there's a reason why bro is saying like ls lart, because think about it. That's easier to remember, right? Like lart versus trowel. Same like ls tac al. Like it's like you're going to come up with ways that are easier for you to remember these options and these flags that we set, because you can really get pretty crafty with the way you're combining them all together. It's also easier to say, right? Like ls tac lart instead of ls tac trowel, I think.
Oh yeah. We're all about efficiency on the command line. So yeah, there's no reason to jumble things up.
Yeah.
Yep, as long as you've got a system for remembering it that works for you, it's all the same. So what are we doing? We can do, did we go over CD yet? Change directories?
Yeah, not yet. So yeah, maybe, we can wrap up a couple more of these, kind of showing like the CD, changing directory, the relative paths and stuff.
Yeah, so first of all, let's print our working directory. So we are in home Ubuntu. So I can cd ... / to go back. Now I'm just in home. And I can cd to, that we start it with a period, by the way, to note from the current directory, we're going somewhere. So I can go to Ubuntu and desktop, and now I'm in the desktop. You can also kind of so you can jump multiple folders at once, and then we can also like cd directly to the root directory, and now we're in the root directory. We can do, oops, not capital H. Ubuntu. Desktop, and now we're back at the desktop. So it's just changing directories, moving up and down the file system. It's the same as doing this from home, going into this desktop folder. You can see the terminator.desktop by ls here. You can see the terminator.desktop. So we're just doing this, but we're doing it more quickly by not having to navigate, by just using the text, the terminal. Make sense?
Yeah. So kind of like how we showed in CMD and PowerShell, kind of going back and forth, traversing through the directories, right? Down and up. Yep. Down the file system, up the file system. Cool.
So let's say, so we can talk about a little bit. Well, do we? How much time do we have left, Anthony?
Couple more minutes. Yeah.
I was just going to talk a little bit about like absolute file path versus relative file path.
Yeah, that'd be good.
Yeah. So right now, we can tell where we are, and we can move places. So right now, we've been moving places relative to where we currently are. So if I wanted to go to the root directory, I can go back to directories, right? Because I'm in home Ubuntu, and that would take me to the root directory. Or I can cd to, I don't know, documents. And that's from where I currently am. But what if I just wanted to go using an absolute file path, which is like the full file path, but you can go anywhere. So I can cd home etc I don't know, let's go pam. So now I'm nowhere near my home directory anymore. I used an absolute file path to just move directly into etc pamd. And then I can do the same thing by going to home, Ubuntu, desktop. Now I'm back at the desktop. So that's it's important to keep in mind the file path that you're using when changing directories, when looking around. Absolute and relative file paths are good to keep track of in your head. You want to know where you are in the system overall, and you also want to know where things in the system are relative to where you currently are. Yeah, also important for scripting.
Oh, that didn't paste well at all. It looked like it was going to paste normally, and then it just got dumped. Anyways, I was going to say, like, you can see on the preview course what we're going to be covering. Yeah, for tomorrow we get into like command line file administration, and further down we get into command redirection and data streams. That's when we're going to be talking more towards variables and such. Yeah. Yeah, cool. I think, is there anything else on this last lab over here?
The CLI? No, I think we hit everything.
Yeah, I think that's a pretty good intro to Linux so far for the day. I think we've probably got another day and a half worth of going through this stuff, like tomorrow and then the following stream. But hopefully, I think everyone can see so far that Linux is not that scary, right? If this is your first time hopping around in it, usually students that first start within IT, when they hear Linux, they're like, oh, like it sounds so foreign. Like, how do I even start with this? Like, what is Linux? So I hope that we were able to provide you with a good enough landing course into the Linux ecosystem and environment and the kernel, the user space operations from it, and how it sort of functions the way that it does. And that you can see that the desktop environment is really not that complicated, right? It's kind of like poking around a Windows desktop at this day and age. And you can see so far that just hopping on the command line, it is a nice experience, just kind of going through the commands, looking at the flags. The man pages are easy to read. Like, Linux documentation is much easier to read compared to Microsoft documentation. It's well structured, and tools all work off one another as well. So I hope everyone has enjoyed their introduction to Linux, and I hope you also enjoyed the last bit we covered in the morning of the introduction to scripting with CMD and PowerShell as well too, because those are also effective in their own right. Yeah. So tomorrow we'll hop into it. and dive right back into the command line and get more action going on over here. And we'll see how far we can go tomorrow. We've got a lot more to cover.
Yeah, there's a lot to do.
Yeah. Awesome. Any questions? Anything? Anyone else? Last. Nice. Thank you, Karina. Yeah. Any last questions anyone has on this portion? Sweet. Nice. Thanks, Hades. Thanks for being here.
Yeah, thank you.
Yeah, you can hit us up. Like, don't, like, out of the stream. We're in Discord. We're all Discord hood rats. We're all we can't help it. It's just live off it as well too. So yeah, feel free to join up. We're around. The other SOC 100 students are around as well too, and leave questions there. We'll be happy to answer in our time. Yeah, glad that the time can work for international audiences too. But I guess before we head off, I want everyone also to give a big recognition for James stepping in today. I think he did a great job. He did a really good job kind of walking you through Linux and going through the commands. So give him a little shout out. He's our first contributing instructor on the stream. We'll see him again tomorrow, and there are others joining. But this is cool. I'm glad that we can do this, and it's nice having everyone here. We're really enjoying it. I think you can tell that. So we're happy to have you here. We're going to continue doing this, and one weekend at a time, and we will get all the way from the IT basics to SOC Tier 1 triage. We're gonna go all the way. So thanks for being with us here, and good job, James. Thank you for today being with me as well.
Thanks. It looks like we converted somebody. They're gonna uninstall Windows.
Yes. Yeah, the true SOC 100 course is to get you off of Windows. That's the true intention. But thank you, everyone. Cool. The recording should be up in a day or so, as soon as I kind of get it edited and timestamps. But thanks again. Have everyone a good rest of your Saturday. We'll see you tomorrow morning, coffee in hand. Be ready to go. We have a lot of Linux cover tomorrow. Have a good day, everyone.
Bye, guys.
Oh, thanks for the follows as well too. Couple of last minute there. Drink water. We will. Thank you. And Starflower as well too. Thanks for the follows, everyone. Have a good day. We'll see you tomorrow.